Cámara caí lo que
Hello.
Hello. It is Subhi only.
Hey, take now.
এইটারে তো অন্য অন করো
ये तुम्हारा जो है ना माइक ये ओनली फुल सर्वर जो बोलोगे वो सर्वर साउंड जाएगा इसको डिस्टर्बेंस करना नहीं कुछ भी हो जाए मतलब नहीं इसका हो जाना चाहिए कि हम लोग ऑफलाइन में कम ऑनलाइन में ज्यादा रहेंगे
ठीक है सर हेलो
ठीक है जो बोलोगे इसको बंद करना नहीं ये बोलोगे सुनाई देगा
এইটা
यहाँ पर नहीं
এইটা যেটা কইবো বন্ধ
ये जो
করবে
है
কইবো যেটা অন করিও এটা না করবে এটা বন্ধ করবে हेलो এটা একটা সুইচ আছে अभी नहीं हो रहा है
इसको भी बंद करना है यहाँ पर जो है इसको बंद करना है
चलो ये ठीक है बेटा आओ किसी लगे नहीं
तो स्टार्ट करें. Good morning, esteemed guest. Good morning, esteemed guest, ladies and gentlemen. It's my great pleasure to welcome you all to this pre-conference talk, which aims to set the stage for the exciting and informative.
अबे ना এটা কোন এসে দেখিও না কোন এটা
Hey,
এইসে কোন স্যার এইসে কোনটা দেখিও তাহলে এইটা তুমি দেখিওনি কিছু এটা দেখিও কিছু আছে না ହଁ এটা ତମେ କିଛି ଦେଖିବନି ଯିଏ ବି ପ୍ରେଜେଣ୍ଟ କରିବ ଯିଏ ବି କି ନୋଟ୍ସ ପେପର ଆସିବ କିଛି ପ୍ରେଜେଣ୍ଟ କରି ଆସିବ ସେଇଟା ପେନ୍ ଡ୍ରାଇଭ୍ ନେଇଯିବେ ତାଙ୍କୁ ଯାହା ପ୍ରେଜେଣ୍ଟ କରି ଆସିବ ସେ ସେଇଠି ପ୍ରେଜେଣ୍ଟ କରିବେ ସେଟା ଡାଇରେକ୍ଟ ସର୍ଭର କୁ ଯିବ ଏଇଟା କେବଳ ବ୍ୟାକଗ୍ରାଉଣ୍ଡ
on है off कर दो.
ଏଇଟା ଅନ୍ ଆରେ ଶୁଣ ସେଇଟା ଗଲେ ମାନେ एक्चुअली ସ୍କ୍ରିପ୍ଟ କାଢିବ ନା ସ୍କ୍ରିପ୍ଟ ଆମେ ସେଟା ଅଫଲାଇନ କରି ଦଉ ନା ସ୍କ୍ରିପ୍ଟ ଆମେ ଫୋନରେ କାଢି ଦେଖିବ ଏଠି କାଢି ଦେଖିଲେ ପୁରା YouTube ରେ ଲାଇଭ ଷ୍ଟ୍ରିମ୍ ठीक है ठीक है काढी स्क्रिप्ट स्क्रीन से YouTube रे लाइव ଷ୍ଟ୍ରିମ୍ भी करोगे ठीक है सर आईसीएमआई तो नहीं के आछो ना आईसीएमआई लोगो लगा एटी बैकग्राउंड रे आईसीएमआई रो लोगो थाउ जेतोले सेमाने जहां बेसी प्रेजेंट करे एटी डायरेक्ट पेन ड्राइव लगेबे सी प्रेजेंट करे तो सेटा डायरेक्ट YouTube रे लाइव स्ट्रीम हो एटी तमे किछ प्रेजेंट करो एटी जहां देखले वो किछ भी नहीं एटे डाउनलोड कर आईसीएमआई भी लोगो अछि ना करे वेबसाइट अछि बा कर जल्दी
आईडी एटा लाइव स्ट्रीम चलछि
हो
YouTube रे ए लिंक पे पठो ना.
से नहीं ना पठेले बटे
अरे लिंक को चाहूं मैं.
कंप्यूटर बात करो तो लाइव स्ट्रीमिंग हो रहा है
ठीक है
विश्वविद्यालय
ये विश्वविद्यालय मॉर्निंग सर ये कहीं लोगो
वेबसाइट डाउनलोड कर दे वेबसाइट में आईसीएमआई वेबसाइट स्क्रीनशॉट ले जा ऑन करके स्क्रीनशॉट ले
ତା ପାଇଁ କିଛି ଗୋଟେ କରୁନା ଆମେ ପୋଷ୍ଟର
ଏବେ ଆଇसीଏମଆଇ ପୋଷ୍ଟର ଅଙ୍କଲ ଆଜି ଗୋଟେ ପକେଇଥିଲେ ଏଇଟା ଷ୍ଟାଟସ୍ ରେ ପକେଇଛି
ଏଇଟା ପକେଇଛି ଏଇଟା କଣ ଦେଖିବ କିନୋ ସ୍ପିକର ବାଲା
ସେଇଟା ତ ଆସିଲା ୱେଲକମ୍ ହେଲା ସେଟା ଲାଗିବ ନା ସେଟା ଲାଗିବ
ଆଇସିଏମଆଇ ର ଖାଲି ଏଟା ଟିକେ ନା ଯୋଉଟା ଲେଖା ହେଇଛି କଣ ଅଛି ଦେଖ ହଁ ଏଟା ୱେଲକମ୍ କରୁଛୁ ଠିକ ଅଛି
ଏଠୁ ଲୋକ ଯା
ନା ନା ନାଇଁ ସେଗୁଡା ତଳେ ରଖିଦିଅ ଏଇଟା ସୋଭେନିୟର ତ
एंकरिंग करदेला
ଏଇଟା
ସାର୍ କୁ ଦେଖେଇଲେ ସେଟା ପକେଇବା ନାହିଁ
ସାର୍ ର ମୁଁ କଥା ହଉଛନ୍ତି
It's my great pleasure to welcome you all to this pre-conference talk which aims to set the stage.
ये फोन तो साइलेंट कर दे
हाँ साइलेंट अच्छ
विजय घंटा से हो
पचास देवी की सर
बिल्कुल है ठीक है इसका आईसीएमआई है ना वेबसाइट वो बेदम लगा वेबसाइट तो नीचे चलेगा ऐसे वेबसाइट में आएगा तो बनाए थे ना अच्छा ये बनाए नहीं थे फोटो बनाए हाँ जो ना वो सुनना जरूर कुछ दिखाई दे कुछ नहीं होगा तो दिखाई दे सारा इन्फॉर्मेशन है
जब भी जगह बोलो नहीं हाँ यही ले खोल डाउनलोड कर दिए कौन कर अच्छी हो ना चलो बस फोटो डाउनलोड
करोगे तो गूगल कर जाएगा ठीक है तो नहीं डाउनलोड करना है
कुछ करना चाहिए
এইটা চলে লাগবে প্রফেসরটা পুরো দিলে আছে তারটা চেঞ্জ করছি
तू कोड चलेऊ
ये भाई डॉक्टर लिखा है ब्लड टेस्ट में रखला है सोना तू मागो
कौन से पठो
सोना तू मागो ग्रुप रे अछि एटा
ठीक है तो मेल को
ସେଇଟା ବୋଧେ ମୁଁ ଦେଖିବି ଗୋଟେ ପକେଇଥିଲା
ମୁଁ କଥା ହେବି
ଏଇଟା ବୋଧେ
हेलो अंकल मो କଥା
हेलो
चेंज ହେଇଥିଲା
हेलो प्रोफेसर दीपक हेलो
हेलो
ମାନେ
କେମିତି ଅଛ?
ପ୍ରେଜେଣ୍ଟ କରିବ
ଭଲ ଅଛି କେମିତି ଅଛନ୍ତି ଆପଣ
ଫେସ୍ ବହୁତ ଚେଞ୍ଜ ହେଲାଣି
ହାଁ
ଆଉ ବହୁତ ଦିନ ପରେ ଗୋଟେ ହେଲା ମାନେ ଖୁସି ଲାଗିଲା ମତେ ହେଲା ଆଉ ଯାହା ହଉ ଏବେ ଆମେ ୱିଦିନ 5 ମିନିଟ୍ ଆମେ ଷ୍ଟାର୍ଟ କରିଦଉଛୁ
अच्छा अच्छा
ହେଲା ଫରୱାର୍ଡ ମାନେ
କଣ ଷ୍ଟାର୍ଟ କେତେବେଳେ କରିବେ
କଣ କହିଲେ
କେତେବେଳେ ଷ୍ଟାର୍ଟ କରାହବ
ମାନେ ଜଷ୍ଟ 3-4 ମିନିଟ୍ ଭିତରେ ଷ୍ଟାର୍ଟ ହବ ଆମର
ଆଚ୍ଛା ଆଚ୍ଛା
ହେଲା
ମାନେ ଏଇଟା ପିଲା ଆସିଛନ୍ତି କିଛି
ଅଫିସରେ ନା କୋଉଟା
ନା ନା ଘରେ ଏବେ ତ ରାତି 10ଟା 9ଟା 15
ହଁ
ହେଲାଣି
ସରି ମୁଁ ଭୁଲି ଯାଉଛି ସରି ତ ମାନେ ସେଥିପାଇଁ ତ ଟାଇମ୍ ଏପଟ ମାନେ
ହଁ ହଁ ହଁ
ହଁ ହଉ ତାହେଲେ ମୁଁ ଆଉ
ହଁ ହଁ କଣ ମାନେ ସମସ୍ତେ କଣ ଅନଲାଇନରେ ହିଁ ଜଏନ୍ କରୁଛନ୍ତି କି
ନା ଅନଲାଇନ୍ ନାହିଁ ଅଫଲାଇନ୍ ବି ଅଛି ଆମର ଦୁଇଟା ରୁମ୍ ଅଛି ଅଫଲାଇନ୍ ଆମେ ରଖିଛୁ ଦୁଇଟା
ଆଚ୍ଛା
ରୁମ୍ରେ ପିଲା ବସିଛନ୍ତି ଆଉ
ଆଚ୍ଛା
ସେମାନେ ଇଣ୍ଟରାକ୍ସନ୍ କଲାବେଳକୁ ଥ୍ରୁ ଦି କୋଅର୍ଡିନେଟର ଦେ ୱିଲ୍ ବି କମ୍ୟୁନିକେଟ୍
ଆଚ୍ଛା
ହେଲା ଆଉ ମାନେ on behalf of the students one coordinator will be communicate with you regarding any kind of the question
ହୁଁ
or any kind of interactions ହେଲା
ହଁ ତ
ଅଛି ଏଇଟା ଆମର ଖାଲି ମିଟିଂ ରୁମଟା so it is only for conducting the meeting
ହଁ ତ ସେଇ ଭାବୁଛି ଲାଇକ୍ around 40 minutes ର ଟାଇପ ର ପ୍ରେଜେଣ୍ଟେସନ ରଖେ ଆଉ 10 ମିନିଟ ର କ୍ୱେଶ୍ଚନ ଆନ୍ସର ରଖିବ ଆଉ
ହଁ ମୁଁ ଜଷ୍ଟ ଷ୍ଟାର୍ଟ କରୁଛି ପିଲେ
आई थिंक म्यूट ହେଇଯାଇଛି କି
ସାର୍ ଆସିନାହାନ୍ତି ହଁ ଆସିନାହାନ୍ତି ନାହିଁ ଆପଣ ସେଠି ଥାନ୍ତୁ ବେଟର ହବ ମୁଁ ଯାଉଛି ମୁଁ ଏବେ ମାନେ ଗୋଟେ ସେକ୍ସନ ଷ୍ଟାର୍ଟ କରି ଯାଉଛି ଓକେ ନଏଜ ନାହିଁ very welcome to Icmib Professor Deepak Toast. Is renowned personalities and great researchers. So welcome again, Professor Deepak. Thank you to accept our invitations as a uh, uh, deliver a talk, deliver a your tutorial talks in the event of ICMIB 2023. So ICMIB 2023, it is a third version of at IJT Sarang. It is kind of the hybrid kind of the meeting will be conducted during this period. Now, it is privilege to discuss about this our speaker informations and other activities. Professor Deepak Tosh is a senior member of IEEE. He is an assistant professor of computer science at the University of Texas at EI professor. Here, Professor, his research focus on addressing the various multidisciplinary networking and cybersecurity challenges associated to create critical nationalities to critical national infrastructure, industrial Internet of Things, blockchains, and tactical battlefields. He works closely with the researchers from the US Air Force Research Laboratory, Standard National Lab, and Army Research Laboratory on development the resilient data and processing of prevalence mechanism for industrial, operational, and technology environments. Basic on this, he basically closely with the different research laboratory, particularly in the defense research labs. His research has been funded from the Department of Energy, National Science Foundation, and Department of Defense. He has authored and co-author of more than 70 peer-reviewed conference papers, book chapter, and journals, and others. Two of his research work on blockchain were also awarded as top 50 blockchain papers in 2018 at Blockchain Connect Conference 2019. He is also a recipient of prestigious NSF Career Award 2022. So, on behalf of this, I say maybe the third version of this international conference, I can say that it is happiest moment to be a part of the systems. Professor Deepak Tosh is a part of the systems, and I believe that he is very sincere in the times, and also he's doing a lot of things for the research activities. Even if he has a lot of assignment, and it is a late night at that place. Okay. Even if a late night also, he's not forget to forget the time of presenting this conference. Thank you, Professor Deepak. So I hope you are comfortable to present your talk before our students, faculties, okay, and some of the peoples are also connected with this online. Okay, it is we are providing the facility for the online and offline, so that maximum people can be achieve these goals. So during these periods, around 700 people are connected virtually, and also means through this YouTube media and the meeting, and also your physical modes. Okay, so it is the very happiest moment for our conference. Thank you. Please, I request Professor Deepak Tosh to start this talk. Thank you.
Thank you, Professor Sethi. Very glad that I could present something to the large number of audience today. So can I go ahead and start sharing my screen? Professor Sethi, can you hear me?
Hello, Deepak. Any issue? You are audible. You are audible. Clearly audible.
Okay. So shall I go ahead and share my slides?
Yeah.
Okay. Okay. Can you see my screen right now? Okay, good. So you all can hear me too, right? Let me know if you can hear me, and then we can start. Okay. Okay. So let me start. First of all, thank you, Dr. Sethi, for inviting me to give this talk. It's my pleasure to give some perspective about my research that I have been doing over these last years. So today I'm going to talk about a specific topic that has been close to my heart, and been working with this specific area for past 4 and 5 years. So this topic is about how do we achieve provenance in emerging ICS and SCADA systems. And ICS SCADA systems means here industrial control systems and supervisory control and data acquisition systems, which are very, very prevalent in many of the critical infrastructure. So you can name the critical infrastructure, could be power generation plants, any manufacturing factories. You can think about like our water distribution system, electrical distribution system. These are all our critical infrastructures, without which we as a society we cannot survive. So the topic is going to revolve around how we can make sure we are going to have a system that will allow us reliable way of operating over that critical infrastructure, and how do we make sure the security of those such systems remain prevalent. Okay, so my talk is sort of divided into a couple of specific sections. I'll give a brief introductory concept about what is SCADA system, because some of you may not know what is SCADA systems and what is industrial control system typically look like. And then I'll give a brief motivation on what sort of security threats lurk around SCADA systems and ICS systems, and some preliminary works, and then I'll go ahead, provide some idea about what we did as part of addressing some of the security challenges in ICS SCADA systems, and then I'll provide some initial results, so that all of you can see where we are, although it's nowhere close to what we can say adaptable to typical environment, typical critical infrastructure environment, but these are some initial starting points, and people can actually take this research more forward. Okay, all right. So again, those SCADA systems and those ICS systems, they are nothing but a form of cyber physical system. Okay, cyber physical means where we have a cyber component and then there is a physical component, which means we have a lot of physical processes ongoing. You can think that let's say you can imagine about our think about our Hirakud dam, right, where we're measuring, or we are kind of controlling the water flow to produce electricity, right? So in that scenario, so there are a lot of physical processes happening. We are measuring how much water level we have in the Hirakud dam, and then how much flow I should be passing through my turbine, and then the turbine has to kind of rotate at a particular speed, and with that, maybe like I will be able to produce a certain amount of electricity, and that electricity has to kind of go forward and get distributed with our typical users. So of course there will be losses around, and all these physical processes, they just happen, and we need to kind of improvise their performance, right? You cannot simply say let the process go just like that. Rather, there should be a way to kind of optimize the processes so that we can get a very good quality of service in each of those areas. So if we look into the overall architecture of typical SCADA systems, like a topological overview, they sort of look like what you see in this picture. So you have some of the field devices where you might have a lot of sensors, like hardware circuit boards, some actuators, and some kind of sensory devices deployed in different type of physical processes, so that you can monitor what's going on. You might be able to track data about individual processes. And then those limited end devices, they actually help you to understand what is ongoing in that critical physical environment. And that information is very, very valuable, because once you know that what is happening, you can take better decisions around it, right? So that information doesn't have to stay with those limited low-end devices. Rather, they have to be forwarded to some kind of server, some kind of master machine, which will collect all these device information, all this physical data, and then it will be able to kind of understand what is the state of this particular physical process. What is, for example, what is the state of let's say my turbine speed at a particular day and a particular time, and how much water is flowing. So all these inner details about a particular physical process, we can understand the state of that physical processes by looking into the real raw data that is collected from individual field devices, right? So here we do see that there is an inherent network underneath each of these critical infrastructure, right? So we have a physical layer where all our sensor devices are kind of deployed, and these sensor devices, they happen to collect a lot of those data and pass it to maybe another hierarchy or hierarchical layer devices. Could be some kind of controller, some kind of remote terminal unit, and that remote terminal unit is going to pass that data to the SCADA master or some kind of server. Sometimes you kind of use or send this data to a very like a database form where the database is typically deployed in a specific device which we call as a historian. So the historian basically keeps track of all the history data about the individual physical processes. So as you can see that if we take out these very technical jargons out of the context, so we have like sensor nodes, and they all communicate with some kind of controllers, and these controllers eventually also talk to some kind of masters, and these controllers are very specific type. They're not like typical devices that we see in our day-to-day life. These controllers have a very specific ability to kind of collect data from your physical devices, and they also have ability to kind of control the sensor devices. Like sometimes you say, well, I have a sensor that is, let's say, measuring temperature, right? And it will tell me if the temperature goes beyond, let's say, 40 degrees or something, right? Then 40 degrees is my threshold, right? So someone has to have the ability to say, well, instead of 40 degrees, let's change that value to 50 degrees. When the temperature crosses 50 degrees, you send me a signal saying that, okay, the temperature has just crossed 50 degrees. So then you, based on that event, you can take some actions, right? So that means the controller has the job of not just monitoring, not just collecting data, it also has the ability to control some of those physical parameters from these individual field devices like sensors or actuators. So in a broad way, I can say that our critical sector is nothing but a combination of a lot of these low-end devices, some of the controlling devices, and some high-end devices like SCADA server and historians and HMI servers. So altogether, they are all networked. They all can talk to each other, but they are not really allowed to freely talk to each other, right? Because in our typical IT domain or typical information technology type scenario where any mobile or any cell phone can talk to any cell phone, or you can talk to any of the devices in your local area network, which is what the architecturally that's how we built it. But in our SCADA and ICS kind of environment, they are really limited on how or which device talks to what device, and what should be the flow direction of particular devices, or the network has some specific limitations that you can do, and there is a reason of why we do that. Okay, and I'll come back to that point in a moment. But as you can see that this is a very cyber, so that there is a cyber backbone underneath of these cyber physical environment, like ICS SCADA situations. So in this situation, it's very critical to understand why do we need to protect SCADA systems? Like why do we even care about cyber, like a security aspect of the SCADA system? So there are multiple reasons. I'll talk about that in a moment. So one thing that I hope a lot of the audiences might have heard about is called as something Industry 4.0. So Industry 4.0 is not a very new term. It has been there for last half decade or so. So here the Industry 4.0 talks about all the we are taking the automation to the next level, where the lots of robots coming in, and the physical laborious activities are now replaced by a lot of these robotic automations. And in that case, this robotic automation will allow a lot of the internal components to kind of communicate with each other. They should be able to take autonomous decisions around altogether, and then they can actually optimize a lot of the processes so that overall productivity is kind of enhanced. So in those situations, our SCADA systems are not really ready to kind of adopt those Industry 4.0's objectives. Okay, so our SCADA systems are, as you saw in the previous slide, they are typically arranged in a centralized manner. So like there is a layer of field devices which basically has to talk to the controllers, and the controller talk to the SCADA master or the historian servers. So there is a hierarchical fashion. So that means there is a centralization component which is managing almost everything. And another important piece is all these protocols, all these devices, they actually talk to each other using some kind of proprietary protocol, which is something that you never see in a typical networking book that we always read about. So we all know our communication protocols, something like TCP, IP. These are all our protocols that we use in typical internet technology. However, when it comes to SCADA and ICS systems, those protocols directly do not apply. So which is why there are a lot of these legacy and proprietary protocols which are defined and designed by a lot of the vendors are basically on use. So as we are moving towards automation, so automation is not stopping. Rather, we are even going further than Industry 4.0. We're going to Industry 5.0, where a lot of small scale decisions will also come to place, and machine learning and AI driven agents will be like taking over a lot of those physical activities, and that's where a lot of the mass customization and cognitive systems will come into place. So in the Industry 5.0. But again, we're not surpassed our Industry 4.0 requirements yet. But the point is, we're making a move where all our physical processes in ICS SCADA environment will be sort of communicating with each other. We'll be collecting data about physical processes, and then we'll be able to perform some kind of data analytics to make an appropriate actions, then understand more about how the physical processes can be better optimized, and eventually my productivity will rise. So there could be a lot of different objectives you can think about. So how my machine floors productivity goes up, at the same time my overall pollution goes down, right? So you can think multiple ways. But overall, if you don't have the ability to collect information about your factory floor or your physical processes, you will not be able to make those correct decisions down the road. Okay, so in this situation, it's very, very critical that we should harden our security posture of these existing SCADA systems by providing some kind of unique approach to address those security issues. Okay, so as we know, the data that is generated from individual field devices, they will be collecting the information about different physical processes. If some kind of maliciousness is going to happen on those physical processes or physical data, you will not be able to make a right decision, or your decision process will also be contaminated. Okay, so which is why we should really care about hardening our security postures. And again, one other thing you might also point out here is, since we are allowing connectivity among all these physical devices, and potentially they are going to use a lot of new communication technologies or new sensor technologies, as we are already in the era of 5G, right, which is coming out of a big push from a lot of the infrastructure agencies, like how to use wireless mediums like 5G or Wi-Fi 6, those technologies to kind of make the communication even more robust. So in that scenario, it is very, very easier for malicious adversaries to even look into those communications, or probably breach some of those some of those ongoing communications. So eventually that has a potential to kind of bring a lot of attack surface into this ICS SCADA domain. So that's, I hope it's clear now that there is a strong need for making or strong need of enabling security mechanisms around ICS SCADA system so that we can potentially stop a lot of malicious activities, and overall processes can actually have optimized result down the road. Okay. So let's talk a little bit about our typical structure of SCADA systems. I think I already have mentioned about these. So generally, the hierarchical structure, they don't come as a non-standard way. Rather, there is a Purdue enterprise reference architecture which everybody follows, and there is a specific reason of why people actually follow this Purdue reference architecture in most of the industrial settings, because the bottom layer, which has to be all the physical devices, where you can monitor a lot of your physical processes, and you can monitor them by deploying a lot of advanced sensors, of course. So we do have several sensors in our typical iPhone you can think of. So sensor technology has become cheaper and cheaper from last decade or two. So now people are even thinking how we can create sensors which can survive in very hazardous situations. So if you think about a simple power generation plant where you want to monitor a boiler. So boilers, probably the temperature is more than 200 degrees Celsius, and you cannot simply add a sensor which can melt in 80 degrees Celsius. So that means the sensors has to kind of designed in such a way that they are rugged. They can actually survive in really harsh conditions. And there are a lot of research has been going around creating new sensor technologies where we can monitor many of those physical situations. And at the same time, they have the ability to adapt various standard communication technologies like 5G, Wi-Fi, Zigbee, or Bluetooth. So those kind of communication models they can still adopt so that they can communicate the data to the next level, which is basically your your industrial or control layer. So in that control layer, you have all those program logic controllers or remote terminal units, which are simply playing the role of collecting data and controlling the devices in the physical layer. Okay, and then we do have a separate layer called as a DMZ, or the demilitarized zone. The DMZ has a specific purpose. So generally, you don't want to expose your ICS SCADA environment to the public. Rather, and again, the public means it could be a regular operator, it could be a regular administrator of a particular electric power company, or like a water distribution company. So there could be a lot of different type of users. It could be somebody is operating the physical processes, but somebody is just looking into the billing portion. So the billing guy doesn't have to have access to your physical layer devices, right? So which is why there has to be some kind of access control provisioned at some layer, and generally that is provisioned through this DMZ, or the demilitarized zones. And the enterprise zone is where a lot of the sort of business specific logic is deployed, where you can expose some of the services on the enterprise zone to outside world, but typically the public can visualize, or the public can actually look into the enterprise decisions or enterprise related data through the DMZ. Okay. So these are again some of the details about the industrial zone, which is our physical layer devices. So as I was mentioning, those physical devices are constituting of many type of sensors, actuators, sometimes even the basic process control devices also part of the physical layer devices. So in this case, one thing that I want to point out is these, what are the vulnerable side of this physical layer, especially. So as you see, the sensors, actuators are actually one of the integral part of our ICS SCADA domain. And somebody, let's say, captures one of those sensor devices or one of those actuator devices. And let's say it has the ability to change that sensor with something else. So you basically has, or the eventual result would be your because of that compromise of device, you get malicious data or malicious process data, which could create a lot of erroneous situation in your decision process. So there are a lot of attacks related to data. There could be a lot of attacks related to the device. So the device could be just shut down, and if you shut down a very important sensor, it could cause a lot of issues in other subsystems, because the systems are not really single or singular systems. Rather, they are all cascaded systems. So something is feeding to something else, and something else is feeding to something else. So if one of the system fails, it could cause a lot of cascading problem down the road. So potentially, if there is a compromise in this physical layer, that could cause a lot of issues down the road. So that is one perspective. And then you look into the remote terminal units or the process logic controllers, who are playing the role of controlling the physical layer devices. And these are also very critical devices in this ICS space, because if you get unauthorized access to some of these PLC devices or those remote terminal units, they could create situations where, like, unnecessarily they can create anomalies. So they can potentially cause some of the devices to kind of shut down whenever they want. And some of the devices can be like, tuned in a different way that was not supposed to happen, not according to the operator's way of operating it. So there are potential malicious scenarios when somebody captures or somebody controls devices in that control layer. Okay. And then there are another component which is very important is the communication protocols. The communication protocols are not like our typical TCP/IP. Rather, they are very proprietary and they're customized protocols. For example, Modbus. Modbus is one of the predominant protocol that is used in many of the industrial communications. So since these are legacy protocols, we cannot simply replace them with our new modernized protocols that we're coming up with. And they have to be there, otherwise those devices simply will not work. But again, these devices were built long time ago, where security was not even a consideration. So which is why this Modbus protocol or the DNP3 protocols, by default, they don't give you the ability to vet your data or to vet the origin of the data or who is actually sending it. So there is no authenticity guarantee. There is no way of making sure that this data is actually coming from the right entity. So all those aspects are pretty much missing in those proprietary protocols. And then when you go to the supervision layer, where all your supervisory devices and the historians that basically collect and maintain data, if some of those devices basically get compromised, then you can pretty much control the whole power plant or the whole cyber physical environment. So it basically, if you go back and look into the use case of a very well-known attack called as Stuxnet, which happened in late 2000 and 2010, I believe. So in those scenarios, they actually were able to compromise one of the control layer device. And then from there, they were able to control the nuclear fusion process inherently. So a simple bug in your system could actually allow an adversary to control almost everything. And recently, there has been also a lot of significant attacks happened in past, I think, past year and two. There was one of the very powerful attack called Colonial Pipeline attack happened here in Michigan that sort of led the pipeline to stop for like a week because there was a ransomware attack happened. So So those attacks these are not theoretical anymore, because we are trying to modernize our critical infrastructure that is allowing ways to people come in through the network. So the point is here, it's almost penetrable. Okay, that's why it's a very important piece of how do we create our systems around or create our security periphery around the ICS environment, so that we can stop a lot of those adversarial activities. At the same time, we can still manage to operate more reliably. Again, this is another component of our ICS structure, which is basically our DMZ. The DMZ's main job is to kind of delimit the perimeter of the ICS network, and it will contain a lot of those sort of like security pieces, which includes like proxies, firewalls, and intrusion detection system. The main job of this DMZ is to limit the access of anybody to your operational technology environment or your critical operation environment. Okay, and if someone is actually able to penetrate through DMZ, that means some rule, some sort of firewall rule was relaxedly created, and nobody actually understood the inner details that could potentially cause a loophole, and that could eventually allow the adversary to kind of do a lot more potential cyber breaches. So again, if I want to kind of summarize the different type of cybersecurity threats around SCADA system, although we are adopting a lot of our standard communication protocols to enable efficient monitoring, but these standard communication protocols are not really created by keeping security in mind. So they have the potential to induce or introduce a lot of the security vulnerabilities. But at the same time, our objective in ICS SCADA environment is always like availability first. Okay, so most of the security folks will say CIA is the order with which we should always go with, like confidentiality, integrity, and availability. But this is flipped in case of ICS SCADA environment, where availability comes first. I need to make my critical service available to the society all the time. Okay, if I can do that, I have to then I can achieve that if I can actually make sure my integrity is preserved. If my data and the processes are actually behaving the way they should be, then I can probably make sure they are always available, because then I can detect if something is wrong. Okay, so that's why the order is flipped in the case of ICS SCADA environment. So, but in our context here, we can achieve high availability if we can control the integrity in some sense. So there are two ways you can address this. You can say, well, I know there are a lot of data is flowing from different layer to different layer. So how do I make sure that I can contain the data flow attacks? So I can say, well, I can stop or I can at least detect if there is something wrong happening to my data. So if someone is trying to disrupt my integrity of data, that's where I can understand if something is going wrong. Or there is another way you can also say, can I understand if a physical process has certain states that it has to move on, and if it is moving in a very wrong direction, that means there is something wrong happened, or somebody has been changing some of the parameters in a very different way, which is behaving erratically. So there are two ways of thinking about. So one is called as data integrity, another is called as process integrity. In the data integrity attacks, the potential problems could be like somebody is fabricating fake data. Somebody is sending a data that is not really created by a genuine sensor device or genuine controller. And it could potentially induce a lot of the emergency shutdown or some kind of malicious behavior. So in this, given that this is our context, we want to make sure that we will be always available. Also, at the same time, we want to make sure we can achieve high integrity, where we can give assurance of my data is never going to be altered maliciously, and my processes are always going to be behaving or transitioning in a normal fashion. Then how do we kind of do it? So we are bound by a centralized model, which is a hierarchical model, but at the same time we are creating a lot of these ambitious goals of having this data integrity and process integrity. So in that situation, so we sort of took a little bit deviation. Like, let's say we don't want to really follow into this traditional centralized model. Rather, think about a next generation SCADA system where we can make sure to achieve some kind of properties like availability, like accountability, but we do want to kind of deviate from that centralization aspect. Rather, we want to have the SCADA architecture more decentralized. So some of the services, some of those devices, they can run separately, you can say they can run on a lot of the so-called top of the cell or off the shelf devices, and we can create a lot of the decentralized network around them. So that means if some system goes down, I have the ability to get this service enabled through another node. So it's in a way of creating high available systems through decentralization. But at the same time, we would like to achieve this, the important piece called the high integrity component, where we do want to ensure that we can achieve authenticity about all my sensor data that I'm collecting from different field devices. At the same time, I do want to make sure that I can trust the data. That means I do have to make sure that the data that or the device which is communicating this data is also part of my network or part of my system. So I do have to have some kind of identification associated to that device, and I can verify that. But these are all good things. These are all good objectives to have. But we also need to consider the fact that we are thinking about deploying these systems in a ICS SCADA environment where resources are not really always available. These devices are always lightweight. They cannot handle a large number of computations, large powerful sort of algorithms that takes days and days to kind of complete. So with that framework in mind, our work is about how do we create a decentralized architecture where we don't want to have any central authority. Rather, the information can be collected from any point and could be distributed over to the appropriate control node or maybe to the historian in a decentralized manner. So that means I will have inherently a high available system. Okay. So, but in this scenario, we would like to make sure that the system that we're designing must be efficient enough, and this should be having a comparable result with ICS SCADA, because these are the systems where time bound is a very strong requirement. I need to have my sensor data sent to my controller in a very time bound manner, maybe like in a three millisecond gap. I cannot tolerate if the data arrives at 10 milliseconds. Okay, then I don't have to make, basically the controller will simply reject that this is not a valid data. So given all these strong requirements that we have in ICS SCADA environment, designing a decentralization is a really, really ambitious goal. But we took a stab at it and said, okay, let's think about creating a moderate version of blockchain. Like, the blockchain itself is a very, very compute intensive platform. Rather, we want to kind of selectively choose some nodes which are moderately powerful, and we can say these are my blockchain peers, which is going to create a very sort of decentralized network. And these control nodes or the controller devices are going to make sure they're going to collect the sensor information from the field layer, and they're going to create they're going to deploy a mechanism to identify who is sending it and how we can verify that identity, and then potentially provide that information to the control layer. So anytime someone wants to know, okay, who sent this data, what happened, at what time this was actually sent, So I can get all the details about my data, which is basically my provenance. The provenance makes sure that I can track, or I can actually verify the origin of the data, and from then what happened until the current time. So if I have the whole audit trail from the beginning of that the data been created, I can potentially prove that my system has been behaving normally, instead of like somebody has been controlling it or changing the parameters around. So here our first objective, of course, we want to kind of incorporate the blockchain as an overlay layer in the ICS SCADA environment to promote the decentralization. But at the same time, we also would like to have a proper mechanism that will allow us a lightweight identity management for individual sensor devices, and the blockchain layer will provide us like some kind of accountability and availability, where we will be able to collectively achieve authentication of my data and authorization of devices. So altogether, I'm going to increase my overall resiliency. So talking about how do we kind of come up with a very some kind of identity creation mechanism for individual devices. These devices are all legacy devices. I cannot simply create a signature out of it and make the device. Let's say it will have a public key, private key pair, which will identify this device as a very unique device, because these are all or some kind of public key cryptography is not really possible in those field layer devices. So what we would like to come up with is how do we uniquely identify them and perform continuous authentication so that we can achieve our Industry 4.0 requirements while avoiding our maliciousness in the SCADA networks. So one idea that we kind of adopted in this situation is called as physical unclonable functions. These are very lightweight cryptographic primitives. They are not really as crazy as like our typical public key cryptographic systems, but rather these are all very customized protocols that you can create around devices, which will work very in a lightweight fashion, and you can extract the unique characteristic of different devices. So it will provide a unique identifier for that device. And eventually, using this unique signature, we'll be able to create the authentication protocol and the attestation protocol. So every time the device is going to produce some data, it will use that signature as part of signing that data and then passing it to the next layer or the peer, which is basically attached to that device. So that way, every time I want to kind of verify who is sending this, I can go back and look into the signature and say, okay, this is actually a signature created by the POP mechanism, which I also know, and I can verify that this device is actually coming, or this data is actually coming from the device that we all know of. So a little bit background about POPs. So you can think about POPs are nothing but a small cryptographic module that we can implement on almost any device. So there are variations of physical unclonable functions. So you can think like any device which has a small random access memory, I can actually collect a unique signature about that device. So what I can do is I can send some unique challenges to that device and then collect the corresponding response, which will create a challenge response pair. And based on that individual challenge response pair, I can create a unique value for that device. And especially even if like you get a similar device, but those hardwares are probably different in very minor sense, they will have a very different challenge response pair, and that will differentiate between one device to another device. So with this challenge response pair, we can store the challenge response pairs and use a key generation algorithm to take the challenge response pairs and provide a separate key for that particular device. And these are very low cost fingerprint generators, which basically works much less complex manner than our other cryptographic solutions. And we adopted something called as a SRAM based or a static RAM based physical unclonable function. So here, what is our purpose or what is the goal, overall goal in this scenario is to exploit the fundamental property of the embedded sensors to generate a unique identity through these SRAM POPs and derive the hash key function so that we can uniquely identify these individual sensors. In a very crude way of how this new protocol that we created, which is SPI, or it's a lightweight SRAM-based POP authentication and integrity protocol, where you can simply think that the field sensor, which is basically talking to the remote terminal unit, and the remote terminal unit is basically communicating with the SCADA master. They first of all have to understand, okay, what is the unique signature for that specific field sensor? Let's actually talk between each other to figure out what is your unique signature. So that has to happen in a closed environment, so that the RTU knows the signature of that particular field sensor. There could be many more field sensors associated to that RTU. So you can do a lot of those parallel conversations between a lot of these field sensors, where they will be able to understand, okay, this is a sensor 1, sensor 2, sensor 3, and everybody is actually implementing the same physical unclonable function module, but their overall challenge response pairs are actually different, which is why each sensor will produce a unique key, and that will identify that particular device. So there are 3 different stages actually happen through in these protocols. One is called as enrollment, or the registration process. In the registration, the RTU and field sensor basically talk to each other as a challenge, just like a handshaking protocol, where the field sensor lets the RTU know that, okay, this is my challenge response pair, and the RTU actually stores that, probably asks for a couple more rounds of challenge response pairs, and then use those pairs together to generate a key, and that key is basically disseminated to the field sensor, saying that, okay, now this is basically a key that we commonly agree on, and that's where the registration ends. And next time, the sensor, which is basically going to send some data, it is going to attach that hash of that data by signing that using the key that was generated earlier. So in that way, anytime the RTU receives the data from that particular field sensor, it will be able to understand that, it will be able to verify the signature and understand that this is actually coming from the right sensor, or which is basically the prover in this case. And that also can get delegated to other nodes in the ICS SCADA environment. So we did a little bit of comparative study with our protocols SPI and with some other POF implementations. And in this case, we understood that our SPI protocol is actually not transmitting a lot of extra data. We were able to limit the number of communications between the remote terminal unit and the sensor, and within that we could be able to register as well as do the authentication. And this is within the limit of what ICS communication requirements are based on the Industry 4.0 standards. There are some security challenges around SPI, because when we are creating these challenge response pairs, when we are maintaining them in the controller nodes. Now you can think that, okay, what if the controller goes down? Can I retrieve back the CRPs? So that's a challenge which we kind of addressed in the next version of this extended work, and kind of distributed the challenge response pair with the blockchain peer-to-peer network. So anytime one node goes down, that CRP pair is actually available on another node, so we can still survive, even if there is a single point failure. But overall, when we looked into the transmission time and the amount of data that was transmitted as part of the SPI protocol, and again, comparatively, we looked into the typical ICS communication protocol, which is the Modbus, and how much time it takes to transmit the data from sensor to the controller node, and how much data is actually, auxiliary data is being transmitted as part of that simple data transfer. So it looks like our SPI protocol is actually having more overhead than the raw Modbus protocol, which is 20 millisecond, but we are actually kind of getting 10-fold extra. But then you also have to consider the fact that the SPI protocol that we're creating is providing you two additional services, which is your data integrity as well as continuous authentication, which the Modbus protocol will never give you. Of course, so in this case, you can think, well, additional overhead is is caused because of the extra services that you are actually looking for. So here we are getting our security services on top of Modbus, but with some cost, which is manageable. But again, this is still under the limit of our ICS ICS requirements or the timing requirements. But in the typical POF protocols, the total transmission time is even larger. Not terribly large, but they're still larger. So we're doing good in terms of other state-of-the-art POF protocols, but comparatively larger than the raw Modbus. So one of the, I probably want to skip ahead, and probably I will. This is another angle. But when we think about creating a decentralized SCADA system, you have to kind of create a model of what if a node comes in and goes out, or comes in, how it will make sure that I am part of this peer-to-peer network. I'm part of this SCADA system, but I do need to verify that who is this new guy coming in? Is this a valid guy? And we are kind of allowing that churning nature in a peer-to-peer environment. So again, it's a simple variation of the previous protocols. We are leveraging that SRAM-based POF authentication protocol, but now applied on a peer-to-peer network. So here, initially, like any node can come up and then say, like my initial network might have only 3 nodes. Now, if another peer comes in, which might be a controller, which might be a sensor. So once you have that as part of the network, it will start to think about, like, can I link this to some of the existing nodes? Then it will search around who are my peers, who could be the potential peers, maybe depending on how close they are, or depending on what are the category they belong to. They're probably part of the field layer, they're part of the control layer. So based on some of the criteria, they will connect to some of the peers. And then they will start communicating about their health data. Okay, I'm active, you're active. So that's how the P2P or the decentralized network remains active throughout. So if something goes down, then the network itself will try to kind of reorganize its own state, and then try to kind of survive down the road. But the typical structure is like, we do have the ability to authenticate, where we will leverage our POF-based authentication to kind of to identify who is that device, and the administrator, which is the device trying to allow the new incoming device to be part of the P2P network, will try to approve and sign sign that particular request, and then add it to the read-only database. So then it becomes part of the network. So we can later do the authentication piece, where any device who wants to talk to each other, they will be able to kind of pass a data along with their signature, so that we can actually authenticate the data is coming from who, and the identity of that particular node. And that continuous verification can actually go on and on through this PAN P2P protocol. So again, we also validated this particular example or this use case in a physical environment where we leveraged 6 of our Raspberry Pis and also some of the physical sensors which are sort of interfaced with our Raspberry Pis. And we configured those sensor to send data every 2 seconds. And we actually used multiple signature schemes on the Spain P2P protocol to understand which particular cryptographic protocol that we can use for signing is going to be effective, and whether our POF-based authentication is providing any better result compared to that. So there are variations of P2P, the variations of public key crypto systems available. So RSA is one of them. SecP 256K1, that's also another one. And ECDSA, which is the elliptic curve cryptography. And it turned out that the ED255519, it was actually created keeping in mind that we can use this public key crypto system in low-end devices, and which turned out to be performing quite well in most of our scenarios. So we also measured the authentication time in both our protocols, and figured out that this ED25519 model is actually playing well. Even if we scale up, like if we increase the number of peers in our decentralized network, the growth is not significantly high. The amount of time that it takes is not really high, even if we go from 30 peers to 70 peers. So our time to verify is actually staying almost stagnant. So again, these are some of the directions that we worked on. But again, there are a lot more in this research to kind of to work on. So I would like to kind of point out a few open research challenges that we're still currently pursuing. So given our SCADA systems require always like a constant check on data flow as well as process transitions, while they always have to be available all the time, we need to make sure that all our components are resilient against cyber attacks. That's a core theme that every ICS SCADA systems will need to have. But at the same time, you also need to make sure, if we're thinking about a decentralized system, can we make sure that our provenance can be achieved through some form of lightweight ledgers? Like blockchain is a good candidate, but the underlying ledger service that we're using is computationally heavy. But there has to be some lighter form of ledger services. And in order to kind of make sure the resiliency across different subsystems, we don't have to just worry about data and devices, but we also need to think about the physical processes, like how they transition, what state they are in, correctly estimating the state, correctly estimating the transition state, and kind of closing the loop around and understanding if there are any anomalous events coming up or any anomalous situations arising. So those are something, it has to be detected well ahead of time, and sometimes they will help you to kind of understand if your operating environment is actually degrading its performance. So those situations can be detected if we have a better way to track the integrity of those physical processes. And also then if we have any way of creating an behavior-based anomaly detector. So that way, if there are some behavioral changes happening, if some devices is behaving erratically, we can actually detect that and probably replace it, which will be much more cost-effective than if that device is actually going to create havoc around other subsystems, which will even more costlier. So those are some of the challenges which we're still currently looking into that direction. So again, in conclusion, what I would like to kind of highlight is the SCADA systems are really one of the powerful systems which affects not just the ICS environment, rather it also affects a lot of the societal implications. So here we just provided a simple way of thinking about what are the important security objectives that you can actually think about and address some of the security challenges in related to the data integrity and device authentication. Candidate decentralized solution which we provided. Again, there has to be a lot more evaluations to be done. A lightweightness of those protocols has to be kind of, again, evaluated. So I'll stop here. And if there are any questions, I'll be happy to take.
Thank you, Professor Deepak, for giving a crowd for you, as it is a midnight at your place. However, you are giving a time, and it is our opportunity to learn a lot of things during your presentations. Okay, so I request the audience having any questions or query for the interaction. Any questions? Those are connected with this Google Meet and also Hall 1 from the Hall 1 Hall 2 audience. Any questions or any query regarding this one? Okay. Sorry? So, okay.
I will have one question.
Yeah.
So, can you hear me, Professor Deepak?
Professor Deepak?
Yeah, I can hear you. If
So, my name is Rajiv Khan. I came from University of Turku and Savonia University of Applied Science, Finland. So you showed in your talk about the Raspberry Pi and different sensors, DSP 1820 and BME and so on. So how do you think that they are connected with the SCADA system, and what that experiments actually you try to get what kind of results from that sensors? Could you please a little bit elaborate on that?
Sure. No, I mean, that's a very good point. So generally, the SCADA systems are very, I would say, customized environments. You typically don't get access to some of the production SCADA systems. So any experiments that you do, it's almost like a mimicking or like emulating the SCADA systems feature. So the way we can emulate a lot of those SCADA networks is to configure some of the Raspberry Pis to behave like a PLC or some kind of remote terminal unit, and then interface some of those Pis with different type of sensors, and then we can create scripts around those sensors saying, okay, you want to transmit XYZ data, but then you have to follow certain characteristic of industrial control system. So generally, you have to transmit the data in XYZ format, and you will transmit with, like, let's say 10-second interval, because that's the requirement. And then you can't send it over TCP/IP. Rather, you have to follow a specific protocol. And there are open source implementations of those custom protocols, those industrial control protocols, like the Modbus or DNP3. You can actually get open source version of those protocols. You can actually configure your Raspberry Pi as a PLC. There is a specific project called as Open PLC, and those Open PLC will customize your Raspberry Pi behave like an industrial controller, and those let's say that the sensors will be communicating their data to that controller, and then the Raspberry Pi will pass the data to like other SCADA systems or SCADA masters. So that's a simple way of emulating your ICS environment.
Thank you very much, Deepak. Actually, we have been doing actually the similar things with, particularly we use this LoRa web to transfer the data from the sensors, and we got actually, and we use this Raspberry Pi, and at one side for the transmitter we use this Arduino Nano, which has embedded sensors like 5 or 6 sensors there. So we transmit those data over LoRa and we tested it. Yeah, thank you, Deepak.
Very glad to get the question.
Thank you very much. Okay.
Thank you, Deepak, for the wonderful talk. I would like to, on my behalf, thank you because I am Alan Patnaik, the General Chair of the conference. See, the onus is on me to acknowledge that you have taken the pain to be awake up midnight and give this talk. I've been with Indian Institute of Science and a former Vice Chancellor, basically a computer scientist. I had a couple of very named questions around this. Okay. Because my apologies, I missed the initial half of the tutorial. We walked in rather late. It was quite interesting. Toward the end, I listened, you were making a comment in the conclusion about the energy consumption. Okay? Correct. Because blockchain is essentially energy hungry. Okay? Correct. Yes. Security, but then, it consumes a huge amount of energy. So when we are talking about everything green, okay, less energy consuming. So this seems to be one of the challenging aspects. We can get robust, secure algorithms, methods. So how does one address this issue? Are you working on that? And the second point is you generally talked about SCADA applications. I guess for other real-time applications like process control, industrial control, telecom, also some of these may be generally useful, even though it may be predominantly power system-driven application what we looked at real-time. And I also saw somewhere a comment you were mentioning that it sends the data every 2 seconds or something you were talking about. Okay. So that too, you cover based on some relative changes because if there is not frequent change, why do I do it by 2 seconds? I mean, we're wasting bandwidth and exactly. Right. Okay. So is it something dynamically one can do based on the process dynamics or stick to 2 only? Because sometimes it may not be necessary.
Right. No, so I think it's a very good point that you are bringing in. So the first point about the energy consumption. So we know we don't want to even waste our energy as well as like my resources, even communicating with my peers about some status which may eventually get invalid. So that's something is a very careful observation, and in this case we are actually trying to minimize that. So if something is let's say we're trying to send a particular data point and we know there is some kind of congestion in the network, then rather than sending it, we just actually observe it and try to kind of make a guess whether my data will reach to the other endpoint within my time limit or not. If not, I will simply wait. I will not send. But then you'll also have to think about balancing the fact if I don't send it, then it might cause some abnormality in the overall decision process. So which one you want to take? You have to take the balance. You have to kind of understand what is your priority about energy consumption and what is your priority about creating extra data points for better analysis. So that balancing nature has to be kind of resolved. And I think the second point you wanted to mention about, it's the blockchain, I guess, right?
like to talk about SCADA applications. Okay.
Uh-huh.
Then we can use it for other real-time process control applications. There are many real-time applications, control applications.
Yes. Yeah. So yeah, for our scenario, we're right now looking into more like non-real time aspects. But in case of real time scenarios, we can actually do that by strictly considering my overall latency and overall packet delivery time. So by a small difference with some of the proprietary protocol, we can achieve that real time feeling about in many of the industrial communication systems. But we have not tested that real time aspect. But that's a very good point. I'll keep that in mind.
Thank you.
Thank you, Professor Deepak. Question from this online and some other rooms query have been come to my point.
Mhm.
The little bit as a whole, questions are almost similar. Okay.
Mhm.
So among the questions, I just read one of these. Any other model for automation available for automation and manufacturing? And another question will be only for the manufacturing, how it is possible? This kind of the question asked from the different users. Just
Right. So again, most of the automation and manufacturing kind of use cases, you could think about a lot of those devices that are being used in manufacturing floor and automation sector. They're coming from very small group of vendors. I mean, I can name a few of those. For example, GE, Schneider Electric. So these are like the real player of industrial automation, and most of their protocols are built on top of like some of the standard proprietary protocols like Modbus and DNP3. So they have customized some of the protocol from their own, for their own purpose. And but most of the time they have the compatibility with the open formats, like open protocols like DNP3. There are also several other protocols. They are also open source, which they typically inherit and kind of build on top. So once you know how some of the protocols work, it's always easy to kind of migrate into and work with other different protocols that will work in manufacturing and automation sector.
thank you. Any questions? Okay. Thank you, Professor Deepak. Now we can say also good night.
Thank you so much. Thank you.
Thank
It was a pleasure.
Nice meeting you.
Now I request Professor Seniority to come over to the dais.
May this flash brighten your day and serve as a symbol of our appreciation for all that you do. May they bring you joy and happiness in the days ahead.
Once again, congratulations and thank you for being a part of this special event. We hope you enjoyed this event. So now, please join me in welcoming Professor Sasmita Mishra, the esteemed head of the Department of Computer Science Engineering and Applications at Indira Gandhi Institute of Technology, Saran. We request ma'am to preside over the meeting. Please, ma'am.
Okay, thank you.
So now we'll request Professor Lalit Patnaik sir to come over to the dais and preside over the meeting.
Saying some addressing the meeting.
So we request sir to say something and address the meeting.
Thank you. Thank you. Good morning. Good morning. Is it on? Okay. Audible? Good morning. President of this inaugural function, Professor Sasmita Mishra, your HOD, and one of the key persons of the conference, Professor Srinivas Sethi, who is the prime mover for the last several years, and tutorial speaker, Professor Sanjay. And we have other invited, I think probably faculty members, in particularly Professor Rajiv, who has come all the way from Finland. His student is going to, co-author is going to present a paper tomorrow. We have from GIT, Professor S.N. Das, who has also a paper tomorrow. He is helping the conference indirectly in different ways, even though he is not from Gandhi, your particular institution, but he is part of this institution, this activity. Yes, okay. He is remotely helping from Gunupur. And young student friends, faculty members, other invitees. So it's a pleasure to be here this morning. I, along with others, was sitting through part of the tutorial. It was quite interesting. That was on blockchain technology in an application to SCADA systems and other applications. And this will be followed by another interesting tutorial, I'm told, on cloud computing. In fact, if you look at any conference, there are two items which are very important, like keynote or invited talks, and another is pre-conference tutorial. That is why myself, Rajiv, we all said that we will come and sit through the tutorials, learn something, okay? In my opinion, it is never late to learn something. Even though you something, you should listen to the opinion of a second person or third person, what he or she has to see. In fact, if you look at most of the international conferences, many senior faculty members also sit through the tutorials, because by sitting through half a day or 1 or 2 hours, it is like taking a capsule to get cured from a disease. You immediately get charged with something. It is humanly impossible for you to get to know about what is happening in blockchain technology, what is happening in AI, ML, and what is happening in IoT, cloud computing, and quantum computing. You cannot know all these things because the advances are so rapid. It is impossible. Okay? So if a tutorial is given, you can sit through, know the basics, jot down some references, go back and set that, because the net is the best teacher for all of us. Okay?
So tutorials are most important parts of the conferences, pre-conference tutorials. So the faculty members, students should take it very seriously, even the keynote addresses, talks, other talks. I think IGIT has been doing a wonderful job for the last few years to organize this conference here. I have been watching. We will talk about a little bit more tomorrow if Professor Srinivas Sethi permits me to talk tomorrow. Okay. As I have been telling everybody, you can organize conferences in Bangalore, Hyderabad, Delhi, Mumbai, but organizing in IGIT Sarang in a remote place, it's something like an NP hard problem. Okay, very difficult. Okay, impossible. If you have a power laptop doesn't work. If you have both of them, you don't get a place. If you have all three of them, the speaker doesn't come. Okay, or the vehicle ferrying the speaker doesn't come on time. There are so many problems here. Okay, notwithstanding all these things, I think the department, the institution has done a wonderful things. And over the last 50 plus years of my service, I have visited engineering colleges from Karnataka, Andhra Pradesh, Tamil Nadu, Kerala, Odisha, Madhya Pradesh, Chhattisgarh, many places, West Bengal, as part of AICT, NBA, NAC inspections, TechCube and all. We see a marked difference between government colleges and private engineering colleges. Pardon me for making that observations. It is a bit tougher to get something done in government engineering colleges, okay? But in private, the culture is a bit different. So with all that thing, you have been able to sustain this conference. The hospitality has been excellent. We have been enjoying ever since yesterday. As Professor Rajiv was telling, Professor Srinivas Sethi is following. It is like he has a GPS system. He is tracking all of us, who is where, what is happening, and all that thing. There is absolutely no problem. I think students also have been a great help, as I can notice, in terms of organizing and all that. And remotely, people like Professor S.N. Das have also provided great support and help to this conference. We will have more of this when we have the chief guest tomorrow for the formal inauguration of the conference. We hope you continue this tempo year after year. I have been begging Professor Srinivas Sethi to excuse me from this for the last couple of years. Okay, I had enough. We should have a young person to take over the general chair so that to come up with new ideas, something exciting. Okay, and this is an opportunity forum where you can meet international speakers like Professor Rajiv. You will know he has come from a country like Finland, which is so very well known in mobile, okay, wireless technology, a small country. You have all heard about Nokia, the wonderful job they're doing there. I was talking to him briefly. So this gives an opportunity for you to talk to them, have network, get to know more and more about that. See, we wanted to have this in offline mode or physical mode for the last couple of years, but pandemic conspired against our strong desire to do so. We couldn't have it. Okay, but this time Professor Srinivas Sethi took a challenge. He said, we'll start with hybrid mode. Let us see. Some will come in the online, some in physical. In fact, just about 10-15 days ago, in a sort of emergency mode, I was hospitalized for a day for a cardiac problem. I was not sure whether I could make or not. I was in two minds. My doctor was not quite enthusiastic. I said, I will take a chance because I cannot disobey what is commanded by Professor Srinivas Sethi remotely. He said, you have to be there, we are waiting for you. So it is always a pleasure to be in this campus. I have heard about this place several years ago. So conferences like this will give visibility to you, and the very fact that a well-known publisher is printing the proceedings in this one. And I'm told he has plans to continue this and take it to different places that will do a good service, particularly in Odisha. Okay. because there are places, after all, there are good students, good faculty members everywhere. You should give them an opportunity to do that. It's not only Bhubaneswar or Raurkela or Bangalore or Mumbai or Hyderabad. Okay, young students should get an exposure about what is this. I'm sure you are doing a wonderful job. Thank you very much. Keep continuing yourself at the department, Dr. Sasmita Madam and your colleagues, okay, including the director of this institute, okay. And I would like to profusely thank the tutorial speakers, both of them, who have taken the pain to prepare. One was up late night, another has traveled all the way from Warangal and come for this. Because without the speakers, keynote speakers, paper presentations, the conference has no meaning. And most important, thank you all of you, because without attendance, if there is nobody sitting here, the hybrid mode or offline mode makes no sense, right? Thank you very much. Wish you all the best.
Thank you, sir. Thank you, sir, for your insightful words.
So now let's give a hearty welcome to Professor Sanjay Kumar Panda from NIT Warangal, who has published over 100 papers in reputed journals and conferences to address the meeting.
Please, sir.
Thank you very much. Good morning, everyone. First of all, I would like to thank Professor Srinivas Sethi sir, as well as Professor L.M. Patnaik sir, to give me an opportunity to come to this campus. Although I belongs to the state of Odisha, I never visited this campus. I served BSSUT Burla for 5 years, NIT Warangal for last 4 years. But it is always a pleasure for me to visit any place. Wherever I am getting invitation from Odisha, I always comes to Odisha to meet my student friends, meet my colleagues, meet my seniors, and interactions, as I said by Professor L.M. Patnaik sir, it is very much important for each and every conference. So whatever work done by the keynote speakers or tutorial speakers, they briefly explain in a conference. So if you are interested in such a field, then you can further do work in that particular field. So conference place gives us a platform to learn the things in a, you can say in a summary, we can learn the things within 2-3 days of time. So today is the tutorial day. In the next 2 days, we have paper presentation in various research area. So I hope you will actively involved in the conference and also learn something which will help you in your future work. Okay, thank you very much.
Thank you, sir, for such gracious words.
Now we welcome Professor Srinivas Sethi, co-chair of the Conference Program Committee of International Conference on Machine Learning, IoT and Big Data 2023 to address the meeting. Please, sir.
Once again, good morning to all of you. Thank you, Professor Patnaik, to be a general chair since 2020. So since 2020, he guided us and encouraged us doing a lot of things in a systematic manner. And thanks Professor Sasna Mishra, head of the department, to carry out the process this year as well. Initially, Professor S.N. Mishra was the head of the department during the period of 2020, and now since 2021 and 2023, Professor Mishra, Sasna Mishra is continuing as a head of the department and organizing chair of this ICMIB conferences series. So I thanks a lot of things for to both of these head of the departments, ex-head of the department and also current head of the department. And finally, we should not forget about this guest like Sanjay Ponda, though he respect me as a teacher, but I'm not a teacher, but direct teacher to him. But he liked me, and so when I give a proposal to him as a tutorial speaker, then he was very happy and giving a consent to present over there. And I'm also thanks to Professor Rajiv Kante is since last 4 to 5 months, I think, having this lot of discussion during this, and he also very much interested to work with our department. I also informed to my professor and head of the department, Professor Sasmita Misra, and also to carry out this collaborative work from this from his institute in our institute. So that is our agenda. And since last 4 months, we work with on this on behalf of this ICMIB. It is a platform giving a collaborative work to the different institute, different department. Thanks to Professor Rajiv, since it is a hectic travels from the Finland to a small village of India, that is Hajat Insurance. And also, I should not forget about this, my friends, Professor Hasan Das from GIT, Granapur, helped me a lot since last 3 months. Though I have connected with this a lot of years, couple of years, but in this event we are closely connected. And before that also we are working with this him for the different event in these other places and particularly GIT. Okay, so as a friend, I thanks to you. And also thanks to my colleagues, my department colleagues, my non-department institute colleagues, and also all the students, student volunteers over this, my virtual modes, online modes, and also in the different rooms, they are allocated, the students are allocated, they are sitting there. And also with thanks to present over these rooms. Thanks to all, and hope you should enjoy these sessions. Thank you very much. And after that, 3 to 5 p.m. we have this new session on that is a project, a small project presentation will be carried out from our students. And hope that our general chair and guests are enjoying that one. Thank you, sir. Thank you, everybody. So may I request our head of the department to close these meetings. Close these meetings. Okay, ma'am. Thank you very much to close this, and we'll start this new session, that is the tutorial sessions. Close it, ma'am. Meeting close. So now I request Professor Sanjay Panda to carry out the process for the tutorial sessions, and
এই আইডি নো আইডি কোন আছে পিভিকে
So, test करियो ना गुड
चल जी एक्सेलेंट So remember the code? Huh? Great. No, you usually use this ID or you are using different ID for different session? It's the same ID. Same ID. এটা বন্ধ করে দেওয়া না কোন না সেটা লগে আমরা না থাও রাইট Once again, good morning everyone. Once again, I thank Professor L.M. Patnaik sir, Professor Srinivas Setty sir, Madam Professor Mishra, and all the faculty members of IGIT and administration of IGIT for inviting me for this tutorial session. So I'll make it very simple because number of participants are more over they are the students. So I'll tell in very simple term. So I'll talk about cloud computing. It's past, present, and future. So if you before going for cloud computing, you should know what is a computing. So there are a lot of computing paradigms are there prior to cloud computing. And if you go to Professor L.M. Patnaik sir's profile, you will find a lot of research work in the field of parallel distributed computing. In fact, he is one of the men behind our supercomputer. You can visit sir's website and you will come to know what contribution he has made for the field of computer science, not only for computer science research areas, but also for the country. So in IISc Bangalore, we have a lab that is called a supercomputing lab, and a project called as National Supercomputing Mission, NSM. In fact, we have a project under that NSM project. So this computing paradigm is not new. It is there from since long back, right? Like you can write a small program in your computer system, like you are writing C++ program, and you are doing computation. Today we are talking about cloud computing. In future, maybe after 2-3 years, you will come to know about fog computing, another computing paradigm. Another few years after that, you can find a new type of computing paradigm like osmotic computing. There is a new computing paradigm in which my research scholars are working. So the background behind these are computing. So you first should know that what is the meaning of computing. Why computing is actually required? Why it is more essential? In fact, why it is more essential in place of computing is more essential in comparison to communication. There is two words, computing and communication. In BTech studies also, we generally study mobile computing and mobile communication. But when you come to computer science field, like cloud computing, we called about cloud computing, not communication. So why we are not talking about communication? Why we are talking about computing? The reason is that computing dominates the word communication. The more important part is computing. Like you have written a very long program. All of you know you have written program. Imagine you have written a program which requires 1 day time to run. Like earlier, people used to submit the program in a batch. They submit a file in batch. Maybe next day or after 2-3 days they are getting their result. But if I tell you, write a program, submit a job, you will get your result after 2-3 days. Nobody is interested in that program. Nobody is interested in that computer system. Everybody knows that we need the result as early as possible. That is the life cycle of computing. Initially computing is there. Today also computing will be there. Maybe after 50 years, 60 years also people do different kind of computing. The only change what we have, that is called as the time. Like if you, nowadays we are talking about i7 processor. Maybe in future some other type of processor will come. So our processors are having multiple cores. But sorry to say that whatever programming language we learn, they are sufficient for a sequential processor, a single processor. We have 2 cores in our system. But are you utilizing the 2 cores? No. That's why I referred to Professor Patnaik profile. You have to learn MPI, message passing interface, OpenMP. What this program will give you, why Python is not sufficient? Because if you have resource, you have to utilize it. If you have 2 processors, you have to utilize both processors. Because when you purchase a computer system, you are paying for both processors. But the way you are writing program, that is sufficient for one processor. Right? You can execute a program with a very fraction of time if it is a parallel program, not a sequential program. Okay? That's why I request you, whenever you are getting time from your academic, try to learn the programs which can utilize the processors, right? Multiple processors or multiple cores. Like if you go for supercomputing, you can type top 500. You can also find top 500 in SARS profile also. That is a top 500 website. What it says, you can type also. You have a smartphone, right? You can type. In top 500 website, you will come to know the fastest supercomputer in the world. And this list is not static. This list is not static. Whatever you are saying today, it may not be there tomorrow. So every 6 months, they are updating the site. Okay, updating the name of the supercomputer, which is fastest in the world. If you see one of the supercomputer, which is in that list, that is having 31,20,000 cores. 31,20,000 core. Our computer system having 2 core or 4 core. So imagine a computer is having 31,20,000 core. So imagine how much electricity is required, which gives a energy efficient. Nowadays we are talking about energy efficient. Like I charge my smartphone once in a month, but it lasts for 1 month. We are talking about energy only in terms of product, right? And you see how much power is required to run that particular supercomputer. All countries are contributing to provide the fastest computing power, right? One of the supercomputer that is called Param, PARM. You can see Param UVA2. These computer systems are developed by India, developed in India. You can see in top 500 list, most of the computer systems you can find from abroad. Our supercomputer is also in that particular list. Not in the top list, but it is there in the list. So whenever you have requirement, first you have to ask whether you have a program to utilize your processor or not. Suppose you are writing addition of 2-number program, right? Usually we write. But what is the use of that program if I have a 31,20,000 core? So I have to think, or we have to think that in what way I can utilize the processors, right? That is the main goal behind computing paradigm, right? So slowly I will tell you. Anyhow, we will discuss this one. So I usually give these 3 examples. Like you have visited banking bank, any bank you have visited, right? Bank. Let us talk about a cashier. Bank, you have a cashier for withdrawal, demand draft, or deposit. Lot of operations we are doing. Suppose a cashier is doing work 7 hours per day with computer system. I'm not talking about other works. Suppose a cashier is working with a computer system for 7 hours. And if you imagine that there are, if you compute that there are 6 working days are there. Total 6 working days, considering Sunday is holiday, and there are 7 hours. So 7 into 6, right? How much you are getting? 42. But how many hours are there in a week, in a particular week? How many hours are there? We are seeing movie 24 into 7. Okay. So imagine 42 hours is utilizing, he or she is utilizing out of 168 hours. So if a computer case is cost is 40,000, then I am utilizing only 10,000. Rest 37,000 time it is completely idle. That gives a clear picture why computing is important. Like you see, for example, newspaper. We usually ask for newspaper, right? Suppose a newspaper is delivered 20 days. Are you willing to pay for 30 days? No. Why? In computer case you are paying. Whether you use your computer system or you are not using your system. Like COVID, due to COVID you are using your computer system. Right to COVID, utilization is very low. Right? Then why should we pay? If you are not utilizing, why should we pay? Like newspaper, I subscribe for 20 days, I have to pay for 20 days. There is suppose a person who deliver milk, cow wala, right? He is delivering 30 days, so I have to pay for 30 days. In a 1 month, suppose I am out of station for 20 days, I will pay for 10 days. So it gives you a picture of service. If a service is provided to you, then only you are going to pay for that particular service. If service is not provided to you, you are not going to pay for that particular service. So that is my first example, where resource utilization is only 25%. Rest 75% of the time we are not utilizing our system. Now, this is a simple study, but if you go for the study conducted by IBM or the study conducted by NRDC, so they have stated in their report that average utilization rate of a personal computer is only 5 to 10%. And if you talk about server, it is 30 to 35%. Okay, we have calculated 25% in the first example. But this real life figures also says that the utilization is only 5 to 10% or it is 30 to 35%. So it needs some new paradigm where like parallel distributed computing is a paradigm which will help us to increase the utilization so that whatever money we are paying, we will get something in return, right? Like I have also given example of Samsung. So nowadays food is delivered while you are traveling in train, right? Like I started Warangal in the morning 9, right? Then I've seen that it reached Visakhapatnam at 8:30 after 8:30 p.m. So I thought I'll book a meal. So you can go to Samsung website or you can book the meal at IRCTC website. Okay, you have to specify your PNR number. Through PNR number, they can get your birth number, coach number, and they will deliver. But what happened? The scheduled time is 8:30, but train reached at 10. 1.5 hours late. Who is responsible for that? They have to be responsible for that. Customer is not responsible for that. Right? So they are telling that what time it is going to reach at Visakhapatnam station, because in this work you have to provide the meeting. So what I try to convince with these examples, if a service is provided, then only you are going to pay for it. Otherwise, you will ask for refund. Any service is not provided, you are asking for refund, right? And computing is a most important paradigm. That's why you should learn the parallel programming in order to utilize the resources of a computer system. Now, all of us are using Gmail, right? Can anybody tell where the server is located? Where the server is located? Any place you know where your server is located? No, we don't know, right? It is located somewhere, but where we don't know. Within India or outside India, that also we don't know. So what actually we need? We are given with a username and password, and we have internet connection. Through username, password, and internet connection, we are able to see our emails. Right or not? We don't care where the server is located, what security policies are enforced to that particular data. We are not looking into that. What we want service. If service is not provided, then we will not create email ID in Gmail. Some other provider will provide better facility, will move to that provider. Right or not? So it says that I don't care where my server is located, whether Google is maintaining that particular server also you don't know. Maybe there is a third party who is managing this server on behalf of your Google. That also you don't know, right? Okay, but the primary constant is that it should connect it to the internet in order to get that particular service, right? So what you can do, for example, you have written a particular program, and in order to run that particular program, you require a high-end server. And cost of the server is not low, like our computer system. Cost of the server is very high. So what we can do, we can take this server from cloud. Okay, you have to simply create one account. Through that account, you can get the server. That's why what you have to do, you go to Amazon Web Service, AWS. I think most of you know, if you study cloud computing. You go to AWS account, you create an AWS account by providing your basic details, your name, date of birth, and other things. You can get free services for 12 months. Up to 12 months it is completely free. What you can get? You can get computation. How many hours of computation? 750 hours of computation per month. How many hours are there in a per month? Calculate it. Calculate it. 720. But why they are giving 750? Why they are giving 750? The answer is that you can run multiple works, multiple instances at the same time. If you use one computer system, it is 720 hours, 30 hours is waste, right? But if you are running two computer systems, so together it is 1440, right? 720 into 2. So you can freely use this resource. You can use this freely resources for 12 months. Not only that, you can store some data in Amazon cloud. 5 GB of data, it is completely free. Right? Not only these services, a lot of services are provided with that account. Try to utilize that resource. What you can do with 750 hours of resource, you can launch your static website. Like government also now initiates for startup companies, right? So if you want to start your own company, then don't host with GoDaddy.com. Because if you go for GoDaddy.com, you have to pay. Simply go for Amazon Web Service, host your website. For 1 year, it is free. After 1 year, you have enough money, so you can go for any website. Right? If you want to store data, you can store also, right? 5 GB of data. Like Google case also, you know, Gmail is providing how many GB? How much amount? 15 GB. Once you exceed 15 GB, you have to buy. So nothing comes to free. For a human period, if it is 60 years, 70 years, or 80 years, so maybe 30 years it is free. After that, you have to pay for that particular service. One day will definitely exceed the 15 GB quota, right? Then you have to pay for that particular service. See, one statement mentioned by Professor Leonard Kelly-Groff, a chief scientist. He was chief scientist of ARPANET. You have a subject called Internet Web Technology. If you go to Internet Web Technology, in the first page it is mentioned. Okay. So in 1969, he mentioned that after 50 years, 1969 plus 50, what is the date? What is the year? 2019. He mentioned that after 50 years, computer is just like an utility. What are the utilities we are using? The first utility what we are using, that is electricity. If you, in summer season, electricity bill is more, winter season electricity bill is less, so it is an utility. Based upon the usage you are paying. Similarly, water is also an utility, right? Now, metro cities, we are getting water through pipe. Okay, there is a meter. So, based upon your consumption, you have to pay. Nothing is free, right? Similarly, early days we have telephone. We have some free units. Let's say 100 units for 100 minutes. After that, you have to pay. Right? So, telephone is also an utility. Water is an utility. Electricity is an utility. So, computer is nothing but, computing is nothing but a fifth utility of the system. So, nowadays, if you need some computing resources, If you need computing resources, you can get that resources through your cloud service provider like Amazon, IBM, Microsoft. So no need to purchase infrastructure for providing the service or using the service. Okay, provider has to take care of that. But as a user, you need not bother about that. Okay. So gas connection is also an utility, right? Nowadays piped gas is coming, right? You can open your phone pay account and see there is something getting piped gas. It's not available anywhere. Okay, some metro cities, except some metro cities. So that is also treated as an utility. Now, all of you will join an industry maybe in after 1 year or 2 years. So you should know about one of the hype cycle that is called as Gartner hype cycle. Gartner is a research and development firm. This particular hype cycle is generally referred by academicians as well as industry people. What this graph says, what is the life period of a particular technology? We talked about IoT, we talked about blockchain. First you have to see what is the life period of that particular technology once you want to implement that technology in your company. So this hype cycle provides you the data. It's like a technology may be new today, after 5 years it may be in the peak cycle, and after 5 years again it will be obsolete. Like I can take an example. If I ask you about Nokia 100 set or 1100 set, how many of you are using? Raise your hand. Only one. Right? So it is less only, right? Because it is obsolete. Nobody is now going to use that mobile phones because mobile industry has changed, right? So life period of a particular technology you can see in this particular hype cycle. Automation is also an important area, not only in computer science, in other areas like manufacturing, or you can say mechanical engineering, electrical engineering. Now we talk about automation. So if you go for this particular hype cycle, you can see the different colored dots. So each colored dots indicates what is the period, life period, whether it is less than 2 years, or it is in between 2 to 5 years, or it is 5 to 10 years, or it is more than 10 years. So whenever you suggest a particular technology for your company, right? So you should refer this particular hype cycle. Again, like top500.org website, this hype cycle is also updated twice in a year. And the latest hype cycle you will not find in public domain. Right? So you have to refer, you have to pay for the latest hype cycle. Now, there is another prediction made by the vice president. Okay, analyst. He mentioned that by 2023, end of 2023, the leading cloud service provider, like Amazon is one of the leading cloud service provider, they will have distributed ATM-like presence to serve a subset of their services. Okay, like you know ATM, right? Wherever you are going, you are sure that there is a ATM, so you will get service. So no need to carry money, right? Similar type, just like an ATM, in future we have ATM-like services in each and every place. Like you can take an example of this COVID-19. Earlier COVID-19, in the initial phase, the testing was done in the major cities. Like in the state of Odisha, it is done in Bhubaneswar. So even if samples are collected in different places, but it's tested in one place. Once it is tested, let's say you are generating report, you are submitting that report for maybe forwarding the same to the user. Or you want to send the critical reports to the government. So for this also you need services. A single computer is not sufficient. Because if you go for healthcare sector, you will see the image size is very, very high. Like if you take a satellite image, today you are taking a picture, it is coming in MB. Right? When you go for space research, or you go for the sites which is having high resolution cameras, the size is very big. So processing, storing these things is very, very difficult. So what you need, if the service is available like ATM, then the user can get the service in the nearby places, so that latency is decreased. Latency is nothing but delay, right? If a service is not available here, you have to go somewhere, right? So it is increasing your delay. But if the service is available here, then the delay can be avoided. So they mentioned 4 important trends. When you join the industry also you will find these 4 trends. The first trend says that cost optimization will drive cloud adoption. Why people are interested in cloud? Why many companies are hosting their website in the cloud? Because of scalability. So one of the example I will tell, this is a non-technical example again. When I met with Professor Rajkumar Bhuya from University of Melbourne, Australia, he told a story related to scalability. Like you go for Ramayana and Mahabharata, when there is a war. At that time, like you go for Ramayana. You know Ravan, right? How many heads are there? 10. What that head shows you? Why Bhagavan shows Vishwavatar? To show power, right? To create fear, right? To the opponents, right? But when you see the Ramayana entire story, you are not seeing the 10 heads in the entire story. Only in the particular part, only you are seeing the 10 heads, right? You see only one head, right? That is an example of scalability. One head can be expanded to 10 head whenever required, and 10 head can be reduced to one head whenever required. Because whenever we are running a business, we don't know whether our business is going in profit or loss. So we cannot purchase the infrastructure. Initially, we don't have money, right? That's why small to medium enterprises, they are heading towards cloud because cloud is easily scalable. Today you need 8 GB, they can provide you. If you want to expand it to 100 GB, it is also possible. Day after tomorrow, you again scale down to 8 GB, it is possible. But if you have purchased a storage of 100 GB, at a later point of time, if you feel that that is not required, if it is not required, that is of no use. Right or not? So, for that reason, people are heading towards the cloud because the cost is optimized. So, whenever you join a company, there is a position in your company that is called a Chief Technical Officer, CTO. Okay? What Chief Technical Officers are doing? They have different plans. One plan is purchase the infrastructure and use your own infrastructure. That is called as in-house server. Plan B is that why to use in-house server? Because it is not scalable. You can move to the cloud. So we have 2 plans. One is our in-house server. Another plan is our cloud server. So generally the CTO, Chief Technical Officers, they usually calculate what is the cost incurred in plan A, what is the cost incurred in plan B. If plan B is less costly, then only we will move to the cloud. Okay? If in-house server is less costly, we will go for in-house server. Right? So, if you calculate, then also you will know that cloud case, the cost is very low in comparison to the in-house server. That is one of the trends. Next is multi-cloud will reduce vendor lock-in. Like you are going to shopping malls, right? So, suppose a shopping mall issues a card to you or a wallet to you. Whenever you go to Reliance, they issue a wallet, right? They ask a mobile number, they attach a wallet to your mobile number, right? Suppose you visited X shopping mall provides you a wallet. Tomorrow your friend told you, no, X shopping mall is not providing you an offer, good offer, you go to Y shopping mall, right? Then you will visit Y shopping mall. Whether the same wallet is transferred to Y? No. That same wallet is not transferred. But this phone pay, Paytm, this is common, right? But the same wallet is not transferred. So that problem is called as vendor lock-in problem. In our childhood also, our parents usually go to a particular store to purchase something. Even if some people say that that other stores are less costly, they are not ready to accept it. So once you are habituated with a particular cloud service provider, with their application programming interface, API, with the libraries, it is difficult to move from one cloud service provider to another cloud service provider. The problem you face is called as vendor lock-in problem. One vendor is locked to you so that you cannot move to another vendor. So what may be the solution? The solution is that if there are some open standards, if there are some common rules, then only you can migrate from one cloud service provider to another cloud service provider. That's why it says that when multiple cloud service provider together provide the services, then only you can solve the problem of vendor lock-in problem. Now, coming to third one, if you want to really work in the field of cloud, you want to be a cloud, you should have your skill in cloud IaaS. IaaS is one of the services that is called as infrastructure as a service. So if you have a skill in infrastructure as a service, that means if you have a skill how to migrate in-house server to the cloud server. Suppose a company is having its own infrastructure. Tomorrow company has decided to move to the cloud, and you have the skill that how you can migrate from your own infrastructure to the cloud infrastructure, then you will get a highly paid job. That's why the third point says that we don't have that skills. Nowadays in market, there are less people who know how to do migrations from traditional infrastructure to the cloud infrastructure. So there are a lot of opportunities you will find when you join the cloud industry. Okay. Next is distributed cloud will definitely increase the availability. It is definitely increase the scalability. Now you can see here, suppose a user wants a particular service, then user will submit that request to the cloud. You have to create a AWS account. Suppose you need 100 GB of storage, right? So you will create a bucket of 100 GB, right? Bucket is nothing but a virtual storage, like Google Drive, you know, right? Google Drive is also a virtual storage, right? Now, not only storage, you can ask for hardware, that means infrastructure. Okay, you can ask for a platform also, like you know, operating system is a platform, right? You can ask for any type of platform. Then your cloud service provider will provide you this service, and you will be charged for that particular service, right? Like early days, we don't have internet in our time, right? Now you have internet in your fingerprint. So we usually go to internet cafe to see our emails, to apply for a particular job. Suppose an internet cafe is charging you 10 rupees per hour. Every day it is 10 rupees and 15 rupees, right? So if you are using for 2 hours, you have to pay 10 into 2 or 15 into 2. Neither computer is yours, nor the antivirus is yours, right? Nothing belongs to you. Only your username password is there through which you are getting the service, right? So whenever your cloud service provider is providing a service, you have to pay for that particular service. Like if you go for AWS site, you can find there are different type of instances are there. What do you mean by instance? Instance is nothing but a virtual machine. Virtual machine is nothing but a part of a physical machine. You have studied virtual memory. In theory you have studied virtual memory. So virtual memory is a concept. It is nothing called virtual memory in our system. It is a part of our physical memory only. Like that, whatever resources we have in our computer system, we can create multiple virtual machines. Early days, what we are doing, whenever we are purchasing our computer system, we generally ask the shopkeeper to install Linux as well as Windows system. Okay, so whenever you switch on your system, it will ask you whether to go for Linux or you go for Windows, right? So both are called as a host operating system, because the space occupied by your Windows system, okay, is not set to your Linux system, and vice versa is also true. So they are host operating system. But nowadays, it is not required to install two operating systems. You install Windows system, install VMware software. You know, all of you know VMware. In VMware, you can access Linux system. So in this case, your VMware is not a part in your system. It is just like a guest operating system. Like somebody is coming to our home. We are sharing room, right? You have your personal room. But when number of guests are changing or increasing, when sufficient space is not there, you are sharing. So what I try to convince you, we call that is a virtual machine or virtual memory, but they are part of our physical memory only. Right? So similarly, here you can see, you can get the service, and the service will provide from the physical machine through VMware or through Hyper-V. There is not lot of hypervisors are there, or virtual machine monitor we say, through which you can create virtual machine on top of the physical machine. So they are not called as a host operating system. They are guest operating system, which takes the resources from the host operating system. Now, if you go for NIST, that is called as National Institute of Standard Technology, US, they mentioned cloud. There is a paper related to cloud. You can view that paper. So they mentioned something called as 3-4-5 model. 3 is called as 3 different services. 4 is called as 4 deployment models. 5 is called as 5 different characteristics or 5 different properties. Like you are using your institute email. Do you have institute email in your IGIT Sarang domain? Okay. Now you tell me what is the difference between your Gmail and the IGIT Sarang account? You have similar setup, right? What is the difference? Hey, you have a student, that's why that credential is given to you. But in terms of facility, what extra thing you are getting apart from Gmail? .com. Gmail.com also. Your institute.com or the gmail.com, both are set. The only advantages your admin can provide you, there is no restriction on 15 GB. Right? But both look similar. But the difference is that Gmail is public, but your account is not public. Okay? Those people who are part of your organization, they can only create an account in IGT domain. Right? But everybody can create in the Gmail domain. So whenever you go for the deployment model, the deployment model is 4 types. One is called as public. Public is for everyone. Anybody can create an account, Gmail. So that is a public service. That is public cloud. But when you go for private cloud, only the stakeholder of that particular organization, okay, students, alumni, or let's say parents, if they are involved, faculty members, administrative staff, they can only use the account. But why it is similar to Gmail account? Because the service is provided by Gmail only, Google only. The service is provided by Google, but admin is the organization. That's why the private cloud is of 2 types. One is called as off-premises, and another is called as on-premises. Just like off-campus, on-campus. What is the difference? Off-campus case, you are going somewhere. On-campus, the placement is within your institute. So now, can you tell me whether whatever Gmail account you are using or IGIT account you are using, is it off or on? If it is on campus, then what happens? You have to manage your server. That server you have to manage. Okay, any maintenance activity you have to do in your campus, but you are not doing that one. This is maintenance is done by Google. Just you have an admin account to create email ID, to maintain your email ID. So this is called as off-premises private cloud, because that is not there in your campus. So you can go for private cloud by trusting a third party, just like Google. Or you can create your own server. Early days we have our own server. In own server, we are hosting our email system. Right? That is limited to our boundary. Just like intercom we have, right? We have phones, right? Intercom. There is a 4-digit number, you can type, within campus you can talk. Right? That is called as a private cloud is of 2 types. One is off-premises, another is called on-premises. Now come to another cloud, that is called as community cloud. Like multinational companies like TCS, Infosys, Microsoft, they are in different place, right? Maybe at New Delhi, another branch is at Mumbai, another maybe Kolkata, another is Bhubaneswar, Hyderabad, Bangalore, Chennai, right? Okay, but when they go for development process, any development process, software development process, you can say, right? What they are doing? Entire software is not developed in a single location. One unit is dedicated for requirement analysis. Another unit is dedicated for coding. Another unit is dedicated for testing. Another unit is dedicated for maintenance. So what they are doing? Together they are building the product or developing the software. So that is an example of your community cloud. So in community cloud, what you have? If multiple organizations comes to solve a common problem, then you can go for community cloud. And if you combine any 2 different clouds, that is called as hybrid cloud. Now come to services. There are 3 services. Let us take an example of pizza as a service. right? Suppose your objective is to prepare a pizza. Now tell me what you will do. Like you want to go for a picnic, what you are doing? So your 2-3 friends has to collect money, right? They will go for purchasing vegetables, masala, other things, right? True or not? So that is an example of infrastructure. That is an example of these ingredients are called as your infrastructure. So once this infrastructure is there, then what you will do? What do you need? You need stove. Nowadays you are not using stove, right? You require gas, you require induction, some medium to cook the pizza or cook the item. That is called as a platform, right? And once it is ready, then you need plate to serve, you need coke. This is called as a software service, right? So these are the 3 different services we call it a stack. You studied in data structure stack. Last in, first out, right? The bottom layer is called as infrastructure. You go to any architecture, you will find the bottom layer is hardware only. You have studied about OSI ISO reference model in computer network, right? Bottom layer is hardware layer. User end, that is a software layer, right? Top layer is similarly, infrastructure is first important. If you have platform, then only you go for software. So these 3 services you can take from cloud based upon your requirement. If you have infrastructure, you go for platform and software, right? So not only these 3 services, a lot of services are provided by cloud. That's why it is mentioned as XaaS, because people come up with their own model. Healthcare people come up with a model called as healthcare as a service. Those people who are working in a sensor field, they come up with a problem that is called as a sensor as a service. Database is a service, storage is a service. People come up with their own things as a service. That's why it is called as XaaS, that is called as everything or anything as a service. That notation we are making, that is XaaS. Now come to these characteristics. Okay. So here you can see in the service attribute. There are 5 service attributes as mentioned by NIST. First is called as your resource pooling. You know about swimming pool, right? From swimming pool, if I take a cup of water level increases or decreases? Nothing will happen, right? It decreases only, but it is not impacting, right? Negligible, yes. Similarly, cloud has a very pool of resources, right? Like Amazon, if you go for 100 GB or go for 1000 GB or 10,000 GB, Amazon is ready to provide it. Amazon will not say no, it will exceed our quota. You have to pay more. 100 GB you are paying less, 1000 GB you have to pay more, 10,000 you have to pay again more, right? So that is an example of resource pooling. A lot of resources are there. In fact, we say it is an unlimited resource. But in practically, there is nothing called unlimited, right? I can say I have 100 rupees, but in my pocket I have 50 rupees. I can say 100 rupees. If I have confidence in my friend, he will give me 50 rupees. In that way, I can say I have 100 rupees, right? Now come to another one that is called as broad network access. You have Facebook account. How you are accessing your Facebook account? Through mobile. You can access to laptop, desktop, to supercomputer also. Who says that there is no medium. Any device connected to internet through which you can get the service. Okay, there is no power like whenever we are designing a particular software, those people who are doing in the final year project, they mention these are the minimum requirement to run this software. But in cloud case, there is no minimum requirement. Now, next one is called as measured services. You know about Tata Docomo? Nowadays it is there? No. Why Tata Docomo is famous? Can anybody tell? Why Tata Docomo is famous? Because before Tata Docomo, the plans are minute plans. After Tata Docomo introduced second plan, all companies are forced to use the second plan. Now we have unlimited plan. It's different, right? So that is called as your measured services. In order to measure a particular service, you require time. You require a unit. You know about throughput, right? We are checking the performance of a computer system. How many jobs are completed per minute? How many jobs are completed per hour? Right or not? That is called measured services. How you can say performance of a system. Like CGPA, SGPA, these are nothing but the performance index for our students. In the similar fashion, here also you have a unit to decide whether it is a fixed price or it is a variable price. Whether it is based upon the supply and demand. One of the example you can say IRCTC premium Tatkal scheme. The price varies with respect to time. Price also varies with respect to day. Right? If you are booking the last ticket, then you have to pay more. Okay. So you are getting the services, right? Whether it is per minute basis, per second basis, per hour basis, or per day basis, you have to choose a unit. That is called your measured service. Next one is on-demand self-service. You visited restaurants, it is mentioned self-service. What is the meaning of self-service? You have to pay, you have to collect the receipt, you have to submit the receipt, you have to carry the food, you have to eat, and you have to also put in the basket. There is no person to help you. Similarly, in the cloud case, you have to create your account, AWS account. Okay, you will create your own account. You have to decide what is your requirement. You have to request to the AWS management console, and you can get the services, right? Similarly, elasticity. I told you an example of scalability, elasticity. We can expand as much as possible. We can reduce as much as possible. Okay, these are some of the examples. Like we have Times of India, right? We have Indian Times, Times of India, other newspapers we have, right? So there is a newspaper called as New York Times. So earlier, New York Times, all the newspapers are coming in printed format, right? So what they decided, why not these printed formats will be available in a web-friendly format so that anybody wants to see the newspaper of 1957 also can see it. Okay, whatever newspaper, nowadays e-papers are coming, right? But early days e-paper is not there. So what they decided, convert everything into a portal so that anybody can access it. So they used Amazon EC2 and S3. Within 36 hours, everything is available in the cloud, in that particular portal. Similarly, take an example of any motor, like marriage party and other parties. We are keeping, we are taking photos, right? At a point of time, what we are doing? You are embedding a music, nice music, and you are giving to your friends to show how the party went, right? So that thing is by Animator. They hired 70 servers because they don't know whether the company is going to be in profit or loss, right? But they have seen people are very much interested in their company. You can visit also these websites. So they increased the number of servers from 70 to 8,500. But can you purchase 8,500 servers in a single day? No. That infrastructure actually provided by cloud. There is another example that is called as little floppy toys. Any days, whenever we go to a new city, nowadays also if you visit Goa, when you go Goa, you have to take a scooty, right? You have to pay 400, 500 rupees. They'll give a scooty. You have to put petrol, and you can roam anywhere. There is no restriction. Similarly, there is a bicycle rental store, right? So that bicycle rental app is developed by someone, just like Ola and Uber, right? And through Google App Engine, they hosted it, and you can see within 1 week they are in the market. So that anybody want to access, okay, want to hire a vehicle, they can hire it. So this is the simple architecture of cloud architecture. Not only this is the architecture, there are a lot of architecture proposed in the literature by various researchers. So this is called as a market-oriented cloud architecture. So you can see the first layer is user or broker. If I am unable to know how to use the cloud service, then I have to ask my friend who knows how to get the service. So through broker also you can get the services in the cloud. The next layer is called as SLA. SLA stands for your service level agreement. Whenever you purchase a particular product, there is an agreement. Like you purchase a refrigerator, there is a warranty card. You purchase AC, there is a warranty card. What this warranty card and guarantee card shows? terms and conditions, right? Within a particular period of time, let's say 1 year or 2 years or 5 years, extended warranty, right? If there's something happens, then they will pay for that particular something. Like that, whenever you are getting a cloud service, first you need to sign in service level agreement. Okay, you have to sign service level agreement between your provider as well as your consumer. So any dispute happen in future, that contract is going to be checked, and based upon that you have to see whether provider has violated or the consumer has violated, right? So like that, the third layer is called as VMs, and these virtual machines are created on top of the physical machines. Like if you see here, in a particular physical machine, I have created 2 virtual machines. In another server, I have created 3 virtual machines. So based upon the capability of your computer system or your physical machine, you can create as many number of virtual machines possible. Okay, quickly I'll tell you about 3 research topics that you can use in your project also if you are interested. There is one of the research area where people are working from long back, not before, after cloud computing, before cloud computing also. That is called as a resource allocation and task scheduling problem. These terms are different, although they use interchangeably, but they are different. Resource allocation means, suppose you want to deploy a particular application, right? You have prepared an application, you want to deploy in the cloud. In order to deploy that application, suppose you need 30 virtual CPUs. So that is called as resource allocation. You ask for 30 virtual CPUs with some configuration, and your cloud provider has provided the 30 CPUs to you, right? Once resource allocation is done, then you can go for another problem that is called as scheduling problem. What scheduling problem says that if you have 30 machines, you have to decide which work is going to be done in which computer system, right? Suppose for this conference we have 20 volunteers. So each and every volunteer is assigned with some role. Okay? So that ordering, in which order they have to do. Inauguration followed by quick or followed by this, some pattern is there, some program is there, right? So that is called as a scheduling problem. So if you are interested, so I have made 12 different baskets here. You can see, not only in the cloud computing, in the field of parallel distributed computing, I can say, because cloud belongs to a parallel distributed computing. So out of this 12 basket, you choose one item from one basket, and you can see the number of research articles are there in that particular domain, right? So if you want to implement these algorithms, okay, you have idea on MPI, like I told you, irrespective of the language, you try to learn MPI. That will help you in future. People can develop the code with a single processor, okay, uniprocessor system, but not with parallel processor system. You have to make your things separate, your things different from others. That you can do by the help of MPI. There is another popular tool that is called as Cloud Sim, developed by Professor Bhuya and team. That also you can use, it is available. You can go for IZIA, that is also an open resource manager. So you can use these tools to implement it. Now here you can see, I am giving you an example of a centralized system versus a distributed system. What is a centralized system? For each and every hour, you have to disturb Srinivas. Okay, as a volunteer, you have to make a call and ask, sir, what to do? It is a centralized system, right? So here you can see the user has submitted his request to a centralized system, right? Then the centralized system has to decide whether to execute in cloud 1 or cloud 2 or cloud 3 or cloud 4. Or you can say machine 1, machine 2 or machine 3 or machine 4. Like sir will tell, you go to X faculty, he will help. Okay. What is the problem with this system? That is called a single point failure. You have studied star topology, right? What you have learned in star topology? Centralized node is failed, okay, or hub or switch is failed, entire network is collapsed. That is happening in the case of centralized system. So what you can do? You can go for a distributed system. What distributed system will say here? The user will request one particular cloud service provider. Let's say first one. Okay. If that cloud service provider is incapable, then it will be redirected to another cloud service provider. So that single point of failure can be avoided. Why that cloud is not capable? because they are heterogeneous systems. Like your system and my system and a server, supercomputer, their capability is different. We cannot execute any type of work in my computer system. It has limitation, right? So in this way, you can execute. And in order to coordinate this system, each and every cloud service provider is having a manager server. So the manager server is handling the resources, whether a resource is free or the resource is busy or the resource is in shutdown or sleep or awake mode. So that you have to decide, right? Like here you can see the application is submitted to the manager server. The manager server decides that it needs to execute in, let's say, first cloud. And some of the tasks can be transferred to other cloud, right? That's why different clouds need to collaborate together to provide the service. So application, if you go for real life term, application is represented in the form of a directed acyclic graph, which we have studied. What is a directed acyclic graph? Or directed graph? You have studied in data structure. What is that? There is a dependency, right? Like here you can see, you have A, right? Once A is completed, then only you can go for B and C, right? Then only you can go for B and C, otherwise it is not possible. So there is certain dependencies there. So in the real life also, if you go, you will find there is a dependency in the different modules. In the software development process also, or any type of applications. Like you are developing different Android applications, they have dependencies. Until a user is registered with your app, how you can track that particular person, right? Or how you can add the payment details of that particular person. So if you go for a heterogeneous system, not only in the cloud, suppose I want to run a particular work in different systems. Let's say I have 3 different systems and I want to run my application in 3 different systems. So it will take different time. Why it is different time? Because their capability is different. Because they are heterogeneous system. So if you go for such system, there are number of algorithms are there. One of the famous algorithm you know that is called as round robin. You studied round robin, right? You know what is the benefit of round robin. Now you tell me what is the limitation of round robin. If there is no time quantum. If time quantum is there, you will say context switching is the limitation, right? What is the drawbacks of round robin? Round robin treats each and every request equally, but in real life, each and every request is not equal. Right? A work may take 1 day time, a work may take 1 minute of time also. But if you give to round robin, it will assign to 2 different processors by saying that there is a fairness. 1 day is not fair in comparison to 1 minute. Right? So if you apply round robin algorithm, again you will find a problem, which is a very famous problem that is called as load imbalance problem or load balancing problem. Load imbalance is going to happen. We call that problem is a load balancing problem. It is there in the website also. If I tell you about Flipkart Big Billion Day, you know Big Billion Day. In the very first Big Billion Day, Flipkart expected that these many users are going to visit Flipkart.com. But the number of users are so huge, what is beyond their imagination. So what happens if the number of requests are increasing? Definitely the performance is suddenly decreasing or your system is going to collapse. You studied also the concept of crashing in operating system, right? So Flipkart unable to provide the services in the first Big Billion Day. So you need a load balancer to see that not only number of requests is equally distributed, but you have to look into how much time is required for each and every request. And not only these workflows are on simple flows, right? If you go for real life, like there are some workflows are there which is used in the field of biology, used in the field of mathematics computing, also used in the field of, you can say, earthquake science. So these are some of the examples I want to show you here. Montage is a workflow, Epigenome is a workflow, SIPST. These are standard workflows. You can design any workflow by writing a simple code, but these workflows are the standardized workflows are used by researchers to check whether they can assign the resources for this particular workflow or not. In what way they are different from each other? Because they are different from each other in terms of their structure. You can see different structure and you can tell that how many processors or how many cores are required to execute that particular application. It is different with respect to different applications. It will come different. Like if you see the last structure, it is more complex in comparison to previous two. Right? So if you are interested, you can look into these workflows and go to the literature, and you can think in what way you can propose your own algorithm where that your result is better than the whatever there in the literature. Now in the first talk also we talk about energy consumption, right? Right? Energy consumption. Like mobile phones also, every day you are charging either one time or two times, right? Based upon your usage. So day by day we are thinking that how we can improve the utilizations. Improve the utilization, at the same time power consumption should be as minimum as possible, right? So if you go for earlier studies, people think that if CPU utilization is increasing, energy consumption is also increasing, or power consumption is also increasing. But it is not true. Like if you see this graph, it is stressed based upon, you can see 6 different IPs. X-axis is your utilization, starting from 0 to 100%. Y-axis is nothing but your power consumption. So after tracing these 6 different IPs where there are different workloads are there, the researcher found that after 70%, the utilization you are increasing more than, it is up to 100%. But after 70%, drastically the power is consumed is more. Like if your system is idle and if your system is running with 100%, definitely your power backup is going to decrease. Right? If your system is loaded, fully loaded, then suddenly your power is decreasing, right? But if it is idle condition, nobody is using. Now my computer is almost idle, or it is running only one application. So in that case, the energy consumption is low. But when you increase the load beyond 70%, it is drastically increasing. That's why people have come up with a various plan by saying that the curve is not linear one. You have to think that utilization should not be exceed 70%. So based upon that, we divided it into 6 different levels, and another level is idle level. So they put different restrictions in 70%, 80%, 90% in order to reduce the energy consumption. Like you can see one of the example I'll tell you here. Yes, see this example. Right, assume that you have 2 servers. One server is loaded with 40% of the load, okay? Another server is loaded with 30%. Let's say both servers are identical servers. One server is loaded with 40%, another is with 30%. Both are identical, means the same, configuration is same. Is it better, or shall I migrate this 30% to here in the first server, which is 40%? So after migration of this 30%, it is 40% plus 30%. Let's say 70%. In the second plan, which one is better? Running 40%, 30% separately, or 40%, 30% in the same server? If you merge into one server, what is the advantage? Second system you can put in sleep mode or switch off mode. Okay, the number of server requirement is less, number of resources is also less, right? But again, if you club into a single server, its power consumption is increasing. Like I told you here 70%, suppose I'll tell you the threshold is 50%. So after 50% is drastically increasing, so power consumption is more, right? But second case, none of the threshold is exceeding 50%. It is 40%, it is 30%. So definitely that is a better one. That's why whenever you are going for the problem of task consolidation, we call this problem as a task consolidation problem. You have to think whether to go for a multiple processor or you can go for a single one. Okay, like here you can see I put a threshold at 70%. Once it exceeds, then if cluster A is having insufficient resource, I can request for cluster B. If cluster B is also inefficient, then I will go for cluster C. Okay, like that I have to manage the resource. And even if the resource is not possible to accommodate by this task consolidation problem, then what you can do? You can violate this particular threshold, because finally you have to fulfill the requirement of your customer. Right? Okay, quickly I'll go over the third problem. Nowadays people are coming with renewable energy. Right? If you talk about your electrical friends, they are coming with different solutions related to renewable energy. Like early days, if you see data center, okay, Google is having different data center in different part of the world. So these data centers are running with non-renewable energy. What is non-renewable energy? Fossil fuel. Petrol you are using, diesel you are using, right? Gas you are using, right? These all are called as your non-renewable energy. What is the demerit? The demerit is that it is impacting our environment, right? Pollution is there. Pollution is because of what? This fossil fuel, right? And you will see also some of the studies says that if you go for United States, they are having 3 million data centers. 3 million data centers. Imagine how many data centers are there, and they are generating electricity through coal. Earlier, our railway also uses coal, right? So coal. You imagine 3 million data center you have to provide power. So you have to think that how much coal is required. So these are not only impacting your environment, but it is costly. That's why nowadays we have come up with solutions related to renewable energy. For example, you can see here the data centers are connected to power grid, as well as data center is also connected to renewable resources. Like we are using solar, we are using wind, right? Other renewable resources are also attached to the data center. And Google claims, Google, if you see, study the Google report, Google claims that they are running their data center with 100% renewable energy. But fact is that although they are running their data center with 100%, but they are not detaching to power grid, because they know non-renewable energy is having limitation. In night time, you will not get sunlight. If there is no wind, you will not get wind power. In summer season, you will not get hydropower. No water. So you have to see how you have to balance this renewable energy and non-renewable energy in order to think about the sustainability of our environment. Okay? So basically, what we are doing in this, so there are some different tasks or different applications we have. You have to assign it to different data center by considering minimum energy. Right? For example, here you can see we have 2 different data center. If you have a group task to assign to the data center, first you have to think that which data center will utilize renewable energy. Because non-renewable energy everybody can do, right? Renewable energy, the cost is low, as well as it is environment friendly. That's why people come up with so many solutions related to the renewable energy. Okay, so there is an algorithm that is called as future ever best fit algorithm, which consider cost. There is another algorithm called as renewable energy, highest renewable energy based algorithm, which considers renewable energy. The data center which gives more renewable energy, having more renewable energy, I'll use that. Another, this FABF model says that I compare the cost of 2 different data centers. The data center which is less costly, I'll use that. So you can go for multi-objective problem also by considering cost as well as renewable energy into consideration, right? So these are the topics. If you are interested, you can go. So as a conclusion, I can tell you there are a lot of works are done in these research topics. There are a lot of areas also there. It is not only the 3 areas of cloud computing. Many people come up with many solutions. Nowadays, people are also solving micro front-end problem. Those who are interested in web designing, you know web page, right? Web page is, suppose you are visiting a particular web page. The web page is loaded, right? But the entire word page for that web page, you have written the code, either HTML or PHP code. But micro front-end says that you have to divide that page into number of sections. Okay, you have to write the code section wise. What is the advantage? In a particular website, if header is taking more time, then body part you can see. That's why people are now trying to provide solution using micro front-end. Okay, in which dependency is also less. Suppose you want to change, let's say institute name you want to write in Hindi also. So you want to change the header part, so rest part is not going to be removed or not need to be put shutdown mode, right? Only you have to change the header part. So why to worry about body part? So only the header part will go in maintenance, other part will be there as it is, right? You can also think, those who are in the final year or pre-final year, you can think to do these works in your project work, okay? And these are also some of the references. If you're interested, you can go for it. Okay, thank you everyone. But if you have any question, you can ask. I'll try to address your question. talk na कौन पड़ेगा तो ठीक है सिद्धन सब देंगे okay please ask some questions because if you have not asked any question either you got everything or you have not got anything volunteers yeah so our system need to be executed in order to execute that we need low resources to execute like minimum processor Intel Platinum any that so recently you mentioned that Flipkart Big Billion Days is crashed due to low resources of system low cloud maintenance so sir my question is that the higher the resources it's better or the lower the resources it's better all the servers are connected to the load balancer. Like I go with an example. That is conducting the conference, right? You have 20 volunteers. You are making a request to sir, but behind sir, let's say there are 5 people, right? So once the request will come to sir, sir has to decide out of these 5 faculties or 5 people, who is going to solve the problem. Sir will redirect that request to that particular person. In the similar fashion, load balancer has to redirect the request to the one particular server. By making sure that a particular server is not overloaded. Because if a server is overloaded, again it will crash. That's actually I told. And lower resources, obviously higher resources is better. But I mentioned here, higher resources also leads to higher energy consumption. Okay. Like supercomputer, you are running addition of program in your computer system as well as in supercomputer. Imagine how much power is consuming in supercomputer. So you have to find for your requirement which one is more appropriate. That will help you. Whether you need a high resource or low resources, that you have to think as per your requirement. Right? Okay, any more questions? Yes. Hello.
So we mostly prefer cloud because it is scalable. We can use other platforms, but we mostly prefer cloud. So there is a term elasticity. So I want to know what is the difference between scalability or they are the same term.
No, dictionary meaning is same. Scalability means you can scale up or scale down. Means increasing the server and decreasing the server. But these terms are same. In dictionary, the meaning of elasticity and scalability is same.
Okay.
What way they are different? Elasticity says that you can do that without any human intervention. Your scale up, scale down will be done automatically. Scalability says that you have to ask for requirement, then your provider has to approve it, then only you can use the service. In the both meaning is same again, right? One process is automatic, the other process is manual. And there are two types of this concept again. One is called horizontal, another is called vertical.
Okay.
Right? You know, apartments, right? Flats. They are horizontal or vertical?
Vertical.
Vertical. Vertical means you are using 8 GB, you need another 8 GB. What you will do? Like our computer system is general 2 GB RAM or 1 GB of RAM. We are adding another one. This is called as vertical expansion. Right or no? System is same, but you have given more capacity. But nowadays people are thinking about horizontal expansion. Horizontal means instead of one machine, I can go for multiple machines. Right? So the term elasticity and scalability is different with respect to automatic or manual. There is no other difference.
Thank you, sir.
Just like you said, virtual memory is just a concept. Is it true for the cloud storage? Like, is the cloud storage is a part of giant physical storage?
Cloud storage, I told you virtual storage, right? Virtual storage in the sense is that in our side we don't have that. Right? You are using your Gmail, right?
Storing Gmail takes requires some storage. So who is managing that storage? The provider is managing the storage. So for user perspective, it is virtual. But provider perspective, it is physical. In that context, I told you it is a virtual storage. Because our space is not consumed. In Gmail, you are not storing your emails in your computer system, right? It's stored in cloud. For their provider end, it is physical. But our end, it is virtual.
Sir, why should a user go for a service provider which uses the renewable energy? Like how the renewable energy is helpful for the user?
Renewable energy is less costly. Initially, the cost is high, but over a period of time, the cost is less.
And
like for example, nowadays you see street lights, right? There is a solar panel in top of that. Okay, daytime it is charging, nighttime it is showing you a yellow light, or red light. So if you use electricity, again generating electricity, if you are using non-renewable energy, that is more costly. That's why you are going for renewable.
And also this is carbon footprint, environment friendly.
Exactly.
And renewable energy is one of the technology that people are using in their different day-to-day life due to its environment friendly and also it emits low carbon, even no carbon.
See, for example, nowadays you know electrical vehicles, right? That is taking us into electrical vehicle only, right? Electric vehicle. So nowadays you can charge your battery and you can go to up to 50 km. Right? Cost is coming 20 paisa per kilometer. Petrol cost it is 3 or 4 rupees per kilometer. So over a period of time, everything is going to be environment friendly, right?
And also it's limited. Fuels are limited. Once they come into hand,
yes,
we must create something which is renewable. So that's the
the biggest limitation is internet. Although we say 4G plus 5G, but we are getting speed in 3G.
Sir, what if we...
If it is not, you are not in a major city, the internet is low only there.
Yes.
Again, you want to deploy your application, you want migration, it also takes internet speed.
Yes.
Then you want to upload a YouTube video, you need good internet connection,
Yes.
otherwise it is difficult. Right?
Yes.
This is the main point. Another problem I told you about vendor.
Vendors, yes.
Right? I told you something in next month, moving to anyone is not practically possible. That is also one of the limitation. Security policy of each and every country is different. Right? Security policy of each and every country is different. That is also one of the limitations. Lot of limitations are there. But in comparison to these limitations, we have advantages. That's why we are using that technology.
Sir, actually I have doubt in computer fundamentals. Can I ask, sir? Yes. So we used since 1945 non-Von architecture, non-Von Neumann architecture. So still now we are used. So any increase, any... Yes, sir. Yes, sir. So what are the future? What is the future of that architecture, sir?
No, in our computer system, we have input, output,
arithmetic logic unit.
we have memory, we have CPU, we have C. The same model till now we are using.
So
in future is quantum computing. Nowadays we heard about quantum computing, right?
Yes.
If the bit is there, you can store 0 and 1. But quantum can think more than that. The future is quantum computing, but again the concept is one new architecture.
Yes, sir. Thank you, sir.
Particular from the other one. Some question is what is the purpose of using VMware?
VMware is used to create guest operating system on top of a host operating system. Right? Like I told you, you have a Windows system, you want to run Linux system or Ubuntu. Install VMware, then you can create Ubuntu on top of it. Right? That is the main advantage of VMware. You can go for KVM, you can go for Hyper-V. These all are hypervisors that you can use in your system.
Another important question asked from the users. Can I implement this in cloud computing? If yes, then how? Can I implement? Please VMware.
VMware, yes. Cloud computing provides you guest operating system through cloud service providers. But if you want to run multiple operating system in your system, you can use VMware. And cloud service provider, they have already their own hypervisor. They are not using your VMware. But like similar type of applications, right? Somebody is using Android operating system, somebody is using Windows operating system, right? So concept is there, right? But a different type of softwares are there, which is different from one technology to another technology. Okay, any more question? Yes, yes.
Sir, I am asking this from the service provider point of view. Suppose I am a service provider and I provide some services for free. It's restricted for up to a period.
Exactly.
But why should I provide it for free?
Like it is not free. I'm saying you. After 30 years, you will see you will exceed 15 GB. You have to pay for Google.
Sir, suppose he's a user and in the he will record maximum of 10 GB from his entire lifetime. And he suppose using the Google Drive, where 15 GB is free. So, like he requires maximum 10 GB, and he is using 10 GB and he will not pay for it.
Yes.
And as I am the service provider, I will not
What is the benefit that service provider is getting?
I will not get any payment from.
First thing is advertising, right? Whatever data they are getting, right? The visiting restaurants, right? Your GPS is off, so everything is off, right? But you are posting in Facebook, they are getting your data. You can go to Google and you can see morning to afternoon, morning to evening, what are the places you have visited that you can show. That is all are related with respect to data. Whatever data you are getting, that is used for analysis, right? And analysis pays more amount. So whatever you are seeing free, that is actually not free. They are getting money from some other places. Like YouTube, nowadays people are posting videos. You know, YouTube is paying them. That's all. So what is the benefit of YouTube? Advertising. You are seeing a particular video. How many times ad is coming? Now it is saying post to like 1 up to 2 up to 2 videos you have to watch. Then you have to continue. That is also marketing. So marketing they are getting government. So it is free for him. Maybe 10 GB is free. He is happy. But how many users are restricting them to 10 GB? Right? You are using many users are going to exceed 15 GB. Now I am using a native domain. So I know as long as I am there in the native there is no problem. Right? Your institute is paying. I am exceeding means institute is paying. But when I exceed my own account, I have to pay. And you cannot change frequently your email address. When a SIM change will happen, I SIM change can give each other. We only SIM. One SIM people used to use irrespective of the provider. Okay.
But is there any challenges other than
security is also one of the challenges. Many people are also working in security. Nowadays, people are working attribute-based key encryption. That is, they also you can look into. Right? Now the data is stored somewhere, right? So how to extract the data? For that, they are using attribute-based key encryption. Right? In this strategy. I don't know much about. Just like a model and security is one of the critical elements you can think of. People have migrated vehicular cloud with the cloud computing. Like you know, airports, parking places, so many vehicles are there. Vehicles are having its own onboard unit, which we call it OBU. That onboard unit is having GPS, having some computation power, having some storage power. Why not use that resources in the parking place to create a ad hoc cloud, temporary cloud? That is also one of the research areas we are working. Nowadays, people are also working with fog environment. Like first one is related to IoT. Any questions are raised in IoT, right? All the data we are collecting through IoT devices. Where we are pushing this data? Cloud. But IoT cloud, there is a huge difference, right? The latency is the major issue. That's why people come up with the solution that is called as fog computing. Cisco started fog. Like in our real life also, we have ground, we have cloud. In between, we have fog. In precision, we are seeing fog, right? So what is fog is going to give you? It is providing an intermediate solution. Like for my smartwatch, right? It is sensing my blood pressure, it is checking my SpO2. If each and every second it has to send to the cloud, it will take time, right? But it can be sent to my router or my gateway or nearby devices, which is available in my premises. Within a delay is going to be reduced. So people are also coming with a problem that is called as fast offloading problem. That also we can do. Any more questions?
Sir, as nowadays, many number of users are using and many big companies are also, they rely
the question, then I'll address this question. How many of you have an SBI account or bank account or say, we have believed that SBI is not doing any kind of fraud. We believe in a system, right? Similarly, in the cloud case, we believe in the system. There is some law and regulation. If they violate the law and regulation, like Facebook is also, you know, right? They have leaked some information, so they are penalized, right? So, system, there is a trusted party. We believe that our bank will believe that they are not going to reveal these passwords. Otherwise, the ATM pin and everything is there in SBI. Somebody is having access to it, it can get it. But we have a trusted system. In the similar situation in the cloud case, we believe our cloud service provider. If cloud service provider violates such conditions, they will be heavily penalized by the government. In that manner, people can solve the problem. Another problem is that, like military agencies, they start working for defense academy. It's a very nice institute at Pune, right? So they are dealing with very sensitive information. Military is more sensitive information than other information. You know, money somebody can store, somebody can take today. You can lodge a complaint and you can get. But military information is not possible. It leads to national security. So they don't trust in any cloud service provider. Because I asked you, where your Gmail are stored? There is no answer. They have their own cloud. They are keeping their data in their own server. They will not leak to any other country. Because that will lead to problem to our country. Right? In that manner, they can solve this problem. A trusted party is the solution. Any more questions, please?
Okay, I have one general question. So, you talk to us about the cloud computing past, present, and future. How this is a little bit about cloud computing and core computing. You mentioned about the latency and data. So, how do you see that? Because I see that cloud is coming closer. Yes, that is, we see that. So, how do you see earlier cloud is, for example, if we want to watch Netflix video, maybe you need to retrieve the data from a data center which is situated in Ireland. So it takes lots of delay and so on. So what kind of we say that what kind of things are for example from cloud computing to core computing, we also say this hybrid facilitation. So how do you see this scenario? How it affects the future?
Cloud is never close to IoT. It will never close to IoT. Okay, cloud is very far away from IoT. The technology which you name, edge computing and cloud computing, is in between IoT and cloud. So minimize that. For example, I will tell you an example. You told about Netflix. People are also using YouTube, right? Suppose in this particular region, somebody wants to see a particular video, right? So you could suppose you are watching this video. So the request will go to the fog device, not to the cloud. So fog device, if the data or if that particular video is available in the fog device, then that will be directly provided. If not, first time it has to ask for cloud. So cloud will give that video to the fog device. After that, if multiple people, like suddenly something happens, so you will see Facebook video, some computing, read something, okay, place something and simply post it. So in a particular region, multiple people are accessing the same video. So that video is not coming from cloud. First time it is coming to fog. Then fog is responsible to provide that video to different users. That's why the delay is decreased. That's why fog is called as a complementary to the cloud. It is not going to replace the cloud. Because fog is not that much powerful like cloud to provide a very large amount of resource. But like a smart watch, you can see and you can immediately see what is the heart rate in the last 1 minute. You can see what is the SPO provided, right? If any something happens, it will give you all that, right? But if I push everything to the cloud, again cloud wants to send a message, but it will be queued. The message will reach to you, like SMS. Sometimes we are sending SMS in the morning, we are getting in the afternoon. So that type of problem will happen. So new technology, what they are doing, like one of my research scholars is working in osmotic computing. Osmotic computing, like you mentioned, IoT, edge, fog, cloud. 4 different layers are there. Who will decide whether the task is going to compute in IoT device itself, or it will go to edge, or it will
fog, or you go to cloud. So that layer is going to be decided by the osmometer. And that is the first survey paper. I will give you that. You can type in Google also. It is published in SCL transaction on IoT. It is the first survey paper you will find in the osmotic population. You can go through that. That provides some decisions. Right? This is a survey paper. It is showing you different decisions that how to make a decision to decide which layer is capable to solve a particular problem. That way it will help.
Thank you very much. So, it is nice sessions. As a teacher, I can say that from the place we use students, volunteers, and the all the ones, they enjoy a lot of things. And a lot of questions will arise and so the speaker attend the different courses nicely and clearly. So thank you very much. So really, he belongs to Odisha. I'm proud to Professor Sanjay. And since last couple of years, we are contacted and we are going to do some discussions. On the level of the Icmib conference, and I thanks to our speakers. Thank you.
Because they need to interest to start before the next one, right? So there was a professor, his name is Professor S. Chandrasekharan. Okay. His name is Professor S. Chandrasekharan. You can search in Google, right? He is affiliated to University of Michigan, right? So he is a very senior professor. He usually travels 250 miles. Okay. He usually travels from his residence to university, which is the distance is 250 miles. 250 miles means it is more than 300 kilometers. Okay. To teach some students. Okay. Twice in a week, we travel to taught two students, right? In some place. Okay. So his friend says that if you are teaching somewhere where it is very far away, you will be highly paid, right? Somebody is going to teach someone 250 miles. Definitely he will highly paid. You know how many students he was teaching at that time? Can anybody guess how many students he was teaching at that time? By traveling 250 miles or 200 miles. Yes?
10.
Huh?
10.
2000? 20. Okay. Two students. One student name is Lee, another student name is Wang. This is not a today's story, this is story of 1957. Why I am telling you this story? Because that professor was not the Nobel laureate, but both students got Nobel laureate in physics in 1957. So what is the moral of the story? I always find in online classes, at least there should be two students, which I can teach, but here I have seen there are more than students. No students are involved in my lecture. Always, but in the online classes, you know, we have less students active, so we have to find like two students. The teacher might not be a Nobel laureate, but he was happy that he is now happy because his two students are in very good position. Always try to be two students to a particular profession. Okay? And I request to meet sir and professor involved because he is having so many contributions. Right? You can go to his profiles, you can find more than 1,000 papers. Interact as a student, so you will get an experience. You will never get a professor like him. Right? It is very rare to interact with a professor like him. So you interact and try to gain something which will help you in your career. Thank you very much for presenting this. Thank you.
So, the new question from the Dr. Portland. I request Professor Rajiv Kante to share some information
regarding these project and research activities. Sir.
So I don't have any like slides, but I will tell you something about myself first, and then from where I belong, and what are my activities, what research I am doing. So my name is Rajiv Khan. I am originally from Nepal. I live in Finland since last 15 years. So 2008 I went to Finland. In 2013 I graduated my doctoral study in information and communication technology from University of Turku, 2013. And in 2014 I did my postdoctorate research from KTH Stockholm, Sweden. I had a very good professor there, Professor Anu Kenhunen, who was my supervisor. So I really love to be here. I'm pleased to be here, and I thank Professor Srinivas Sethi. And we have been discussing quite many things since last 5 months. Maybe you little bit think that why I came from about 2,000 kilometers from Finland to this remote place. You might think that why I came here. So see, I will tell you about what kind of purpose, what is the best thing you heard about Finland? It's a very small country. How many of you have known about Finland? Yeah, please. Sorry? Yeah, he is saying happiest people in the planet. Happiest people. Why happiest people in the planet? Have you read something? Yeah, so world ranking 1. Yeah, please sit down. So the idea is there you see the best system is one is education system and another is healthcare system. They have very good healthcare system and very good. For example, my son is studying now he went to university this year. He never need to pay any single money when he goes to school, even for higher education. Education is completely free and education for all. So these are some of the things. Of course, it's not possible, particularly in India, I would say, because it's a huge country.
very big country, and probably, have you heard the like the population of Finland? It's just 5.5 million people. So you imagine, maybe Bhubaneswar is 2-3 Finlands will be in Bhubaneswar probably, 10 million or 15 million people. Something I will tell you about my research topics, basically what I'm doing in Finland there. So I have a couple of affiliation. I am senior lecturer in Savonia University of Applied Sciences, which is situated in the central part of Finland. And then I have also affiliation as a senior research fellow and adjunct professor at University of Turku, where I guide some of my PhD students. So mostly they are working on artificial intelligence. At Savonia University of Applied Sciences, we say applied sciences. Applied sciences. So meaning that what you are doing, what you are studying, for example, how you relate with your applied day-to-day life, how you apply that. That's the big question. So in applied science universities, there is one program, we call it Bachelor Degree Program in Internet of Things. So we have a program, Bachelor Degree Program in Internet of Things, and I'm leading that Internet of Things program at University, in Savonia University. We have in a European level also, there are, I think, very less actually Internet of Things schools actually. What Professor Sanjay, Professor Sanjay and also Professor Patnaik sir mentioned in the, so they mentioned somehow very many things actually. So you probably heard, and I love that many of you have asked the question. So the things are now cloud computing, then IoT we are talking about. So the thing is that if we say this IoT, Internet of Things, so Internet of Things, usually when we say Internet of Things, we usually try to think the low profile devices. Low profile devices. So the biggest challenge in the low profile devices, because if you have a LAN system, for example, well-established LAN systems, you have all the standards ready-made. You utilize that algorithm, security, and all those things, and your data is secured. But while we talk about Internet of Things, we have these devices, for example, low profile standards are not yet made already. So it's really very challenging now to get your data. For example, you have like different sensors and you get, and it goes to the cloud, for example. So that kind of things we are doing. One of the projects currently we are having now, where we have four partners actually. One partner from Denmark, one partner money, and two partners from Finland, two universities. What we are doing basically, we are creating new learning environment for a smart factory. Or I think someone mentioned about the automation technology. So one of the projects which we have now, a smart factory. So in smart factory, this Savonia University of Applied Sciences, we are responsible for particularly two things. Sensors data collection, and its analysis in real time, which was my part. Actually, I did some of the things. And another part is data-driven manufacturing. So one of my colleagues actually leading for that one. Similarly, there are another partners from Denmark. They are working on collaborative robots. Have you heard about collaborative robots? Or we also call it cobots. Any of you, have you cobots? Cobots, we say mainly robots. So robots are quite highly used in industrial environment. So nowadays there is a new term, cobot, or we also say jobot also. There are new terms are coming. So our Danish partners are working on this collaborative robots, meaning that how the robots, if in machine to human interaction, how it does not harm human being or another machines if this is around. How it is possible? It's possible due to the sensing technology. You know, sensing technology. If you have maybe, how many of you are electronics and communication here, guys? No, all computer sciences. Yeah. So usually sensing technology is one of the thing that can be used. Similarly, we have another project with this UCN drone project. I mentioned a little bit about. So, you know, Europe is really thus Nordic countries are very innovative in the sense that they're trying to do always new things. And this I say to you that you read all the things which are there in the literature, but in your project, in your thesis, I suggest that you try to come up with the new algorithm or new development methods. So this is my, so they are really doing very innovative. So all the countries like Finland, Sweden, Norway or Denmark. So I see this kind of thing. Now, do you have any questions, anything? Maybe we make a little bit interactive. What do you want to know for Internet of Things, for example, or about Finnish education system? Do you have any questions or anything? Yeah, collaborative robots. So collaborative robots, meaning that you have robots and you give command to it, you train the robot to do a specific tasks, right? So that specific tasks is done by the robot in industry. Some robots can do heavy welding, heavy soldering machines. You might have seen in the smart. So collaborative robots mean that there is a interaction between human and robots. So it has some technologies. So that technologies can be like sensor technologies, and it collaborates with the human and other machines. Therefore, we call it collaborative robots. Any other question?
Two robots will collaborate together in communication.
Sorry?
Like we are in conversation between a robot and a human.
Yeah. Yeah, actually, I have some videos there. For example, we have one Dingo robot, which is run by 5G technology. We have our own private 5G network given by Nokia. We are using that. So one robot is taking out from the for the packaging, and another robot it takes to the, so that they are like correlate actually. And another thing is that, for example, in assembling also, for example, there are certain stations. For example, there you need to go for quality check. There are some, for example, there are one we have used this 5G technology where it measures the vibration, how much vibration it can withstand. Another cross point we put, for example, there it was image processing. So the product which is made by the assembler, is that right or not? It checks with some templates, and if it is okay, it puts it in one place and otherwise another place. So of course it correlates not with human but also with the other robots. Power generation systems, yeah, actually we are relying more. I think Professor Sanjay mentioned we are in the daytime, we are you are utilizing low power, solar power. So in Finland, actually you can Google a little bit. So you see that we have in the summertime, we don't have all the time it is sun all the time. At 12 o'clock also I can see the sun. Actually we are a little bit north. So the thing is that we have, for the power, we use basically on, and now this is a war actually, situation with this Ukraine thing, but Finland is most relying on nuclear energy, and also they have some thermal power, but mostly they are using wind power also during the ocean, and they collect, store it, and transmit it also. So that kind of facilities is there. But I think this Germany has some problem with Germany has rely on more on this fossil fuels, petrols, and all those things. So they are facing a lot of problem now due to this war thing. Because 60%, I heard that 60% of the energy actually comes from their fossil fuels. So they were really in Denmark. Actually, they also rely on this liquid LPG, petroleum gas. So that LPG, so that they rely on their home systems are like water heating system is always LPG, and LPG is really sought out. There are nothing you cannot buy, and price goes so high actually. And so this is the issue actually here. Anything else? Yeah, this is actually short. I have so many videos actually in my computer to show you. Maybe I don't know. So, but we are doing a lot of things on sensor technology, robotics we are doing, and then also we are doing this UCN drone project. In one of this UCN drone project, we have done putting this bird sign actually. You know, in the power line, when birds are flying, they collide with the wires and they are killed. Do you know that? So this is a very common problem actually. So we have done with one company that like bigger one hollow spherical things we put during using the drone actually, and there are so many electronics behind that. So that kind of. So this is shortly what I am doing and what is my research area just to you. Thank you.
Thank you, Professor. It is a highly qualitative talk from the Professor Kante. And so once again, thanks. And thanks to students, colleagues, and present over the meetings to having the patience to listen the different tutorial talk, and also the special talk from this Professor Kante. Thank you. And I request our volunteers have a bouquet for Professor Kante.
Thank you.
Thank you.
Thank you.
So I hope all of you enjoy this morning session. The next session will start from 3 o'clock. 3 to 5 project session by the students. Okay. Project sessions. Little bit project as well as demonstrations. So I think 10 or 11 project has been placed. 11. So some of the PPT, some of the going to this poster presentation like this. So have a meet again at the seminar hall session. Okay, thank you very much. And once again we'll meet. So
another city.
Yeah, we can take one photo with the students also.
Yes, yes.
Hey guys, you can go back. So
They will stand there, sir, so that we will be staircase.
yeah,
We will get the flag.
or we can do like this from there. Nothing is there.
Or make a panorama style. Okay, no issue. You also come and join me, sir. Sir, I supported carry.
Yeah.
Yeah, this is yeah, my district will get so that it is a chance to manage. Our idea will be halana so episode
Sir,